There we go. What do you have? Two offers. Right. So, let's see. Do you have any attendance, like online?
The audio is not great, by the way.
I'll try to get closer to the right.
I'm just wondering if it would be worth putting that on the floor near you.
Right. Is that with sound?
It's a bit distorted.
Can you hear me? Maybe I could sit down here.
You just stay like that.
I could just sit right in front of it. Well, that's a bit awkward. I guess we'll do this without sound.
I think my phone is actually going that way.
Does that make any difference?
I think so.
Yeah?
I'll let you know.
Okay. I'll just stand right in front of everyone and try not to get in the way of this. Well, there's nothing really interesting to look at there. Let me start off by welcoming everyone. Thank you all for attending this magnificent Swedish APL user meeting. And as Morten suggested, why not make a little bit more room for our Scandinavian friends and turn it into a Scandinavian APL user meeting, or a scandal, as Morten put it. I'm very glad to see not only Danish people, but well, we've got one person from Serbia, one person from Germany. Morten claims several nationalities, and well, we've got Indians from Gothenburg, but you're Swedish now.
Yeah,
so you're Swedish, okay. Right, last time we Brits, well, they're quiet and kind, they're making a big fuss. We've got two Brits here, my colleagues Sam and Jake from the UK. We'll probably never hit the topic of today if we continue down this route. But yes, we've got one Syrian as well. Right. In the last meeting, we discussed whether or not we should stop presenting ourselves and talk about coding. And we are trying out this series of meetings where we will talk about specific subjects. The web services sounded like something chic, hip, or cool. I don't know what the in word is now. Yeah. So we're APLers, we do things a little bit better, a little bit later. So 10 years after it's hit the world, we start looking into it. Nah, that's not fair. Web services. Most people in the meeting claimed to have dabbled with it at the very least and had some experience with it, and we're curious to talk more about it. So let me just start off by asking if there's anyone here that doesn't know what a web service is. You can leave them. Right. Okay, no hands. I don't know if we've got any online people here, but no. Right, so what is a web service? Anyone wants to have an explanation?
Remote procedure call.
A remote procedure call, I hear from the back. Yeah? Anyone against or add to that? Well, I think it's a bit vague because I think most people that work with software might have an idea of what web services are, but I don't know if anyone has a clear, distinct definition of what it is. I would not claim to have the exact definition of it, and I'm sort of grown up in this Google era where you say a web service is any piece of software that makes itself available over the internet and uses a standardized XML messaging system. Do you agree with that? No. XML is used to encode communications to a web service. Okay, let's stop reading there. So clearly, there are different views on what web services are. But I think if we take a step back and, well, either look at more reliable sources like Wikipedia, we will. I think we can agree on one thing. A web service should be a service that is platform independent and provides a service for any sort of client endpoint. So a client endpoint that isn't specific to a platform, that communicates with an agreed standard, that typically that would be either XML or JSON or a similar transfer mechanism that is sending requests and receiving it over. May I say the HTTP protocol? Is that the very definition of a web service?
It's not very web otherwise.
I'm sorry?
It's not very web otherwise.
Yeah. Well, I was going to say the HTTP protocol, and with my subject in mind, my topic is WebSockets, and WebSockets is a protocol that isn't an HTTP protocol, but it's sort of an upgraded protocol on top of HTTP. So I will count that in, if I may. Right. So that's a very long introduction, in my opinion, because I've already run into 10 minutes into my own presentation. I've got so much I want to show you that we'd better get started, I guess. Right. Let's see. Web services and WebSockets. Let me start an APL session and see if you can all see that. Does that read well? Should I increase font sizes, etc.?
Yeah. That's fine.
Yeah. Right. WebSockets. Do you know what the WebSocket is? Standard. Let me see. The WebSocket is a way to provide something similar to a standard TCP socket, but over the web. So typically, when you have a web client and a web server, you communicate over the HTTP protocol, and that communication is always client triggered. The client asks the server for something, a resource, a page, a remote procedure call via SLOPE or something like that. All that goes through a client-initiated request, and the server responds in some fashion. What that means is that a connection is established from the client to the server, and the server does the handshake and responds appropriately to a request. There isn't any way for the server to initiate communication to a client over the HTTP protocol. To solve that problem, another protocol was developed to start a communication between the client and the server, but to keep that connection alive for as long as they want and allow the server to initiate message to be sent to the client. So it's a little bit like going around the circle where you establish a connection, you set up a protocol communicating, and then you decide to not drop it, but keep it alive for as long as both parties are interested. This enables the server to send messages to clients. And when is that useful? Good question. I spent a bit of time implementing WebSocket in my server 2 actually, and then upgraded it to run on my server 3. And then thought about what sort of features I could build to demonstrate WebSockets. And I came up with, see if it starts up. Right. Rumba. Oh, that's brilliant. I've got a typo in here. A very interesting web page. I've kept it all very simple because I want to demonstrate the code behind it and I want to avoid overcomplicating things. So this is a very, very simple web page with 3 different examples. And I will try to invite you to join this. I don't know if you've got your laptops up and running. If you would like to try to connect to that IP address on that port, so it's 10.21.16.20 on port 88.
On which network?
It's the Sky High. Right. I will open up a couple of windows. See if we can keep these side by side. Right, we've got someone on there already. Hi, Ender. Hi. When I got this sample working, I rushed into the living room with a big smile on my face and showed my wife. Said, "Look what I've done." And was met by a blank look. And after a quite awkward moment, she looked at me and said, "You know, I've got this thing called Facebook. They've got an amazing chat room. I can show you how it works." So I know I'm not reinventing. I am reinventing the wheel, but the point I wanted to make was that having a chat application is a typical case where you would want to get as immediate responses as possible. I'm not claiming that WebSockets are the only way to do it, but being able to broadcast messages to listening clients as soon as you get them in is a good example of where a WebSocket would be useful. It logically makes sense that when the server receives a new message, it can trigger the broadcast to the listening client. An alternative option, of course, is what I called the toddler approach. It's also called SSE or something, and a long-haul version of that, where the client, like a toddler, asks the server every second or so if he's got any status change to report. Are we there yet? Are we there yet? Are we there yet? Do we have a new message? Do we have a new message? Do we have a new message? Which, of course, is causing a lot of overhead because the client repeatedly sends a request to the server and asks for a response. So it's taking up resources on the server side. An alternative approach, of course, is to just say, are we there yet? And the server waits, and then when someone sends a message, it says yes, and sends a response back to the client. Non-call is what they also call that approach. So yes, there are ways of coding around this, but the natural way would be to use Focus, where there is an established link. You know that your clients are waiting for some information. The connection stays alive, and you just broadcast messages. Right, I've got another example. The voxel painter. Well, let me maximize this and see if Ender is kind enough to join me on this one as well. There are some instructions for how to control this, but I guess this is what people would call a Minecraft sort of thing, where you've got this board with boxes. I think I just flicked it around too much. I'll just re-code it. So it's too easier to navigate this. You can swivel it and turn it up and down and around, navigating it. I haven't written this. I'm not claiming to have written this, but I took it as an example just to show when you would want to do this sort of WebSocket sharing. Someone is building on my little voxel world. Using the numbers 1 to 6, you can change the color of the boxes, and you can collaboratively build up a world. I've just taken this from an open WebGL project library it's a sample from 3.js. So I've just downloaded this, and what I've done is put the man in the middle. I've injected myself in the middle of the code where the user instructions are called, and I'm sending them to the server and then broadcasting them to everyone who's logged on at the moment. So all user interactions are broadcast. Another example is where you would want to broadcast messages between clients. The last one is a bit more mysterious. My last demo here is where the client doesn't do anything. There is no user interaction from the client end. Just needed to find my actual session here. So if you are connected to it, you'll see the text there describing what you may or may not do. And I will manually create a table here on the server end and just demonstrate how triggering something on the server side generates new content on the client side. So if we do something like this, it gets pushed to the client and then rendered in a very simple table. Again, no styling to keep it simple and make it easy to follow the code. And if I change a value here, say Gil, you see how that's immediately reflected there. And I can do a little scan here. an example where we, for the duration of a second and the frequency of 100, update or switch a bit on that 10 by 10 grid. And every time a change happens, it's serializing and sending the data to the client and rendering it. And if we increase that, we can see that it doesn't quite manage to do frequency of 500 per second in this implementation. But basically, that means that it takes about 2 milliseconds to serialize and send the data to the client and render it on the client side. 2 milliseconds per 10 by 10 grid. How important is it that a client sees a big data table in real time, if we call it real time? It's really down to your application. Maybe in some applications it is important. This way you can push, and I have to say, oh, hello, what happened there? I have to say that this implementation is in no way optimized to deal with small changes to small parts of a bigger grid. This is just forecasting the entire grid every time a change is introduced. I'm not going to debug that, but I thought I'll just show you what the code looks like for this bit that is broadcasting the message. So I've got a trigger function with some names defined, and every time any changes made to these variables, it gets all the open WebSockets for this URL, finds the client, and then serializes the table and sends it to the client. So this is the bit of magic that sends the data to the client. Right. I'll show you 3 examples of when WebSockets are a better choice to traditional web services, as it were. WebSockets add the transport layer for web services. Any questions at this point where you think, well, like Morten, well, this isn't a web service, or what's the point of this? This isn't applicable to us. Well, tell me more about what other things I can do. Thank you.
Very interesting.
Right. So, a web service, RPC. Peter said RPC. Well, there are protocols that there are frameworks that use the WebSocket protocol to provide an RPC service. JSON RPC is an example of that, where all you do is establish a WebSocket connection to the server that provides the service, and then you use an established mechanism of sending JSON serialized requests over the WebSocket, and you get a response back. So that's a web service. It's on top of WebSockets. It cuts out the overhead of establishing connections. It arguably can deliver faster throughput because of this. And it's relatively easy to use, especially, I think, where the client is a JavaScript application, where the objects are already in JavaScript, basically objects. They just simply serialize, send through to the server, and back comes a JavaScript object.
Are you using a standard JavaScript binding library for this? Have you written your own?
No, I got someone here mentioned that they were experimenting with Angular, and what I wanted to do was demo how we use Angular as well for our Cosmos project, and I wanted to just demonstrate how you could use a framework like Angular to drive data. So this particular example is an Angular application. So let's take a look at the different parts of this. Let's see if I can find it elsewhere at the project. Right, live table example. Hope you can see all that. There isn't that much to it. We've got a couple of libraries, the Angular library and our application code. A little bit of text here with information, and then further down we define a little table using an Angular mechanism, which is creating table rows by repeating through a vector of vectors. And within each table row, it's then creating a cell, a TD cell, for each item in that vector. We also have WebSocket status and the name of the table within double curly, which is the format that the Angular framework is using for injecting properties.
So ND repeat an Angular.
Yes, it's a directive. Thank you. So with Angular, it's an MVVM model view model framework to map data from a model to a view and back. And if we look at the application code to go with it, we've got a controller, which I call practice controller, with a scope, 3 different properties in the scope, the status, the table name, table rows. I establish a WebSocket connection to this URL, live table, and when it's opened, this callback is fired, which is simply setting the status property in the scope to connect it. And we've got a similar thing on close, so it's updating status to disconnected. And when it receives the message, it's parsing the data that is received, and then sets the properties in the scope, and the $apply is basically a mechanism to trigger the update of the view. You need this when you deal with asynchronous changes to the scope. Right, so those scope properties relate to these curly, double curly names that we find in the HTML file. And that's all there is to it. These 2 files, plus the Angular library on the client side, and on the server side, we've got very simple. There we go. Not that simple. Oh, sorry, clearly I'm not awake. It's very simple because I don't have any user interaction, so I don't actually have that code in a separate my server page because there isn't anything listening for user interaction. the server-side code was what I showed you earlier, which is the thing that's generating, let me see, which was this data binding namespace. Hello. Why does this happen? It seems to happen once in a while.
Why does what happen?
I lose connection to the session. It just freezes. There we go. Yeah, I
have you got suspend threads on error enabled? Right. Maybe. Right, all the way over. Yeah, pause on error. You might want to untick that.
Okay.
Is that on by default?
Yeah. It's on by default because that's the safe setting. Right?
Okay.
If you have a server that has 100 things happening a second,
yeah,
then you want to pick that. So that if you have an error and you need to debug it, there will be no moving part.
right.
But sometimes when you're debugging a server, you have a problem that people block the server thread. And then if one of them is in on your way, I'm not sure exactly.
In an external DLL call.
I'm not sure that will solve your problem.
Okay, now I can see. Okay, that explains it.
Yeah. We are experimenting with the new ideas to allow you to declare threads as service threads, so that all your application threads will block, but
right.
things that are running on machinery.
Okay. Right. So yeah, apologies. I probably started in the wrong end, but this is the server-side code. There isn't any client-triggered action on this last example. So because of that, I'm retrieving active clients whenever a change is made in the workspace, and then broadcast it to the client using this send text method. So so that's all you need. These lines here and those two files for the Angular framework to display the data content. There isn't anything else to it. And if we look at the other examples, I can't remember where my server is it here, pages. No, I'll check the source code instead. So similarly, for the chat example, we've got this bit here. To create a WebSocket endpoint in my server, you create a class deriving from the MySocket, which is the new class I've introduced. And the MySocket class exposes some public methods to as callbacks on a new message being received. So there are binary messages or text messages or other control messages that you may receive. All of those are exposed using this mechanism of overriding the defaults. So if you're not interested in handling any of the other events, you don't need to do anything. This could be an empty class. If you're only interested in text messages, you override the default on text method, and as an argument, you get a WebSocket instance that contains the payload and methods to send data. So in our the chat application, this particular piece of code is dealing with fragmented WebSockets, which is something I just want to test to make sure that it works, but it's not required. All you need to do is receive a message from a client, the argument is the client instance that you received. So you inspect the data you received from the client, and then you broadcast it to all the open WebSockets that you currently have to this endpoint. And there are some helper methods in here. So get open WebSockets when called from MySocket instance will return WebSockets that are still open and that's connected to the URL of wherever that chat file exists on your file system. Yeah?
You put the same line of the code twice. Almost exactly.
Sorry, where is that?
Well, I mean, the get open WebSockets. I mean, what's in on the completed fragment transfer is essentially the same as what else.
Yes. No, that's what I was saying. Ignore this part here because it was something I was experimenting with.
No.
Was to deal with fragmented messages. So what you need for your chat is this bit here. Oh, I should cut it down before too late. So that's the chat version. I should add that I forked the My Server project for this just to try it out. I haven't asked Brian to merge in the changes yet. Mainly because
Brian will be joining us after lunch. When it's
right.
Breakfast. I mean, when it's
time
when it's a sensible time to get up in the US.
Yeah. So we can look at that then. Right. If you are, I mean, if you have tried My Server before, you'll know that my pages are sorted dialog scripts, and by default, if you navigate to a page relative to the web root, so in our case, the web root is the WebSocket server folder, and by navigating down to /voxel/index.html, it will serve this file, and if you do /voxel.dialog, it will instantiate this class and let it render the request. And basically, to create the WebSocket endpoint in My Server, all you need is this file here, which is deriving from a MySocket. It will deal with the upgrade of the protocol for you. So once the client has connected, you don't receive any requests until they start triggering these text callbacks, at which point you can handle the request as you choose. This is a voxel example where, as I said, I put in a third man in the middle sort of thing to catch all the events and store the building process in a vector that I've just called hash.games, and then play it back to new clients. New clients make a special request to get the board.
Short question. Do you have any ways of rejecting a WebSocket connection?
Of rejecting a WebSocket connection?
If clients ask to upgrade to WebSockets, will you always accept that, or do you have a way to say, from the server side, to say, no, we don't want to upgrade to WebSocket?
Well, if you don't have a MySocket page on that URL, then it won't connect.
The SwedAPL application would like not to have the WebSocket.
You mean like that? No, we're not discriminating. Why would you do that? Everybody's welcome to the kit. No, I haven't worried about that yet. I can't remember if I'm also allowing you to override the upgrade attempt, at which point I guess you could.
You would reject that as a project.
Yeah.
Race or religion?
Yeah, exactly. Well, it could be that your web service is limited to Swedish APL users. No, I don't know.
Basic.
Huh?
Maybe you're too basic.
Yeah. Well, that's a fair point. I mean, if you're thinking about load balancing or restricting it that way, then yes. But then it wouldn't be limited to WebSockets, perhaps. As in, you might want to limit the number of connections in general.
Yeah.
Right?
What about HTTP2? That's supposed to have some sort of server push related functionality. Can that replace WebSockets? Or
I haven't actually looked into 2, and I won't repeat what I've heard, but it hasn't been good. It doesn't sound very promising, but I don't know when. We'll see more about it, I'm sure, soon. My topic was actually to show how I've implemented this in both my server and Rumba, but I'm fully aware that people probably don't know what Rumba is. Nobody says anything, so. Yeah, it's a dance. Just like a conga, Rumba is a dance. One-man third thought that the My Server project was getting too big to do simple things and wanted to write his own because he's an APLer. So he created this Rumba project where he's writing an HTTP library which offers both client and server code to initiate connections on the HTTP protocol or to serve connections. So HTTP server and client capabilities. And we found ourselves using almost none of the fancy features of My Server in Cosmos. So we happily tried it out. We've been trialing it for a month, and I took it upon myself to implement WebSockets on that as well, just to learn more about Rumba and to see how well it fits in with things. And I now have my sockets implemented in that as well. Rumba isn't giving you all these easy, what is it called, Ewok features, or have you abandoned that name now?
Well, I mean, and that's the generation of the user interface.
Right.
Another layer. No, they've not done that. I'll try to summarize that a bit later.
No, the name I meant.
Oh,
I can't remember if it's still referred to as Ewok, but
no, it's actually now referred to easy as a
Easy Ewok. Okay. Is that the dance? No, it's happened again. Morton. If I don't look at it, it gets upset.
Maybe that you put a thread on a wait to Conga.
Maybe.
And it's not responding until you come back from that wait. It's in a DLL call. You might get.
Right.
And then once every 30 seconds or something, you get a time slide.
Okay, so I've got about 14 minutes to just quickly demo Rumba and what Rumba is like. To create a server in Rumba, we can take a look at our little, well, I'll show you the Samba version of Rumba. Well, from the outset, I was told that I was not to interfere with Rumba too much because it's supposed to be a lightweight and small HTTP library. So I've tried to avoid changing the core code of Rumba, but to implement the WebSockets, I was forced to interfere a little bit with Rumba, and I had to give it another name because it was supposed to be an extension to it, so I called it Samba. Yeah, I know, this lovely names. I'm sure you all agree. But in its simplicity, you only need a few lines of code to start a server, and what you the core important details here are to define the port that you want to listen on, context namespace where all your callback functions will sit and serve requests, and the entry point here, so the on request callback that is triggered when you get the request to the web server. So there's a few lines you need to define, and you're up and running. Because Rumba is so lightweight, it doesn't actually handle much like static file handling. That's too much for it because it's not supposed to deal with static files, right? So it's arguable if you really need it. As a standalone web server, you would need to be able to serve static files. But in my experience, sitting behind Apache or IIS to serve all the boring stuff and handle the majority of the traffic, and leaving the APL to just deal with calculations or getting out resources, special APL resources, makes it snappier. So if you don't want to put it behind IIS, etc., you need to worry about these other things of serving static files and setting content types accordingly, etc. But if all you want to do is provide a web service, then this is all you need, because you wouldn't expect to receive any requests for any static files. You would get a JSON RPC call and you would serve it. Right. In Samba, in this demo server, I've got similar callbacks that we have in the my server version. We've got the on request callback, which is first checking if this is the WebSocket, if it is handling the WebSocket. If it's not the WebSocket, it serves the index page. And if it isn't asking for the root, then it's trying to serve the static file. So this is my static file handling code, which is allowing me to run this demo. And if we look at the handle WebSocket, simply just checking, is it the chat service or is it the Bosfor service? And looking into these ones, we get a slightly more cut-down version of what we were looking at before. But in essence, it's the same thing. It receives the message. It sets the date property to the current date. That's serializing it again, and then sending the message to all the connected clients. And the voxel. I don't know why, but these ones tend to get smaller than traditional functions. So it's the same thing that we did before handling the game, the voxel painter example, but slightly smaller. Right. Okay. So if I start this example, we should see that it's doing more or less, well, exactly the same thing as the other example. If anything, I have done a little bit more thorough work on the Rumba version of the WebSocket implementation. So it's slightly snappier. If it actually ran. Yeah, I shouldn't have done this. It was going so well until I ran the last demo. Let's see if any of them work. What does this work? I have to change something here that I can't remember. Oh, there we go.
Wi-Fi disappears for a little while.
Huh?
The Wi-Fi disappears for
Ah, okay. Maybe that was it. Right, okay. Let's just do it now. Right. Yay! Should have done that. Okay. Well, it was a bit optimistic to try to squeeze in both the demonstration of a new library, a HTTP library, as well as WebSocket. But I can report back that my findings for the Rumba library is that it is faster because it's not trying to do that much, so it is a little bit snappier. It's supporting HTTP 1.1. I know Joachim mentioned 2.0, but 1.1, yay! My server doesn't yet. I think it's still on 1.0. And the main difference between 1.1 and 1.0, noticeable difference, is that it's managing keep alive connection, which means that if you serve a page with, say, 20 static files with all the CSS files and small images, etc., the browsers could make 5 simultaneous connections to your server and ask for 10 files on each connection and get them funneled through quickly. With my server, each request is a separate connection with its overhead, and it's closing down the connection after each reply.
And if you do same here stuff, it's probably even more.
Yeah. I mean, the reason we put our system behind Apache initially was because of the slow response. All in all, to serve a big project with lots of files, it took about between 2 and 8 seconds if served directly by my server, and it went down to half a second behind Apache. And with Rumba, we're still behind Apache, so we haven't actually made the most of it, but it's faster when you get multiple requests.
What we're actually looking at is probably taking Rumba and using that as the foundation for my server 3.1.
Right.
Because all that excellent work has been done already. It would be crazy for us to redo that work. But then maybe also approach Rumba from below and actually put some of the HTTP protocols for each conduct, so that you can throw away maybe the lowest level of code in Rumba and get WebSocket support, and it maybe you know 1.1, I guess. Maybe not. I don't know. Yeah.
I won't promise anything, but I'm aiming at for 1.1.
1.1, yeah. So the ability to sort of send and receive entire HTTP messages be pushed down into the C layer.
Right.
And then maybe we'll get very close to the Apache when that is.
Well, I must admit, for my own purposes, I'm quite happy sitting behind Apache because
there are other good reasons to sit behind.
There are so many other advantages, but if you're playing around and you just want to get something like a standalone web service trialed out and developed, then it's great if you can do it without. And in fact, that's why one of the reasons I put in this static file handling, just to avoid having to include Apache in this demonstration. Sava? Or no, okay. Any other questions? I will, as I said, the my server version of this is available on GitHub, and the Rumba version not yet, because I have yet to talk to Formancer and find out if he's happy to incorporate the WebSocket part of it. And also it's still under development, run by itself. I mean, it's working as far as I can see. I haven't found any obvious bugs in it or anything of the sort, but it hasn't been publicly released yet, so I'll need to have a word with him to see when he's happy to release it. And any other questions, if you want to try it out on your own or complain, I will be far, far away from you. I'll be here for the rest of the day. Okay, thank you.
I work at Compute Medical on an application called Take Care, which is a large electronic medical record system. So it handles all patient-related documentation in hospitals and primary care centers, private GPs, that sort of thing. So appointments, case notes, medication, lab replies, all of the medically related documents. And our customers are typically very large regions or county councils in Sweden. We have a tiny installation in Malaysia as well, but otherwise we're in Sweden. So it's an enterprise product, it's a larger product, and we have large enterprise customers which have many architects on staff and non-functioning IT departments. And this, this means that web services in our world means SOAP. So no WebSockets, very little REST-based services, but SOAP. And SOAP is the simple object access protocol, and here anyone who has used SOAP, you can laugh now at the simple prefix, because it's a humongously complicated and complex protocol. The basic idea is simple. It's to perform. Actually, it's not that simple. It's to enable sort of object remoting via XML over some transport, which of course is abstracted, but in practice it's always HTTP. So you send and receive XML messages, and the XML messages are very long, verbose, and complicated. And there's a very complicated type system for all this, which is XML schema. And XML schema was designed to support both the object remoting of SOAP and the requirement of putting HTML into XML in the form of XHTML, which was sort of a failed standard which no one uses anymore. So all of this means lots and lots of complexity, both in the type system and in the whole idea of object remoting, where you're supposed to be able to, for example, trigger an exception on the server, which gets serialized into an XML message, which is then supposed to trigger an exception in your code, and you're supposed to have methods and objects, all this sort of stuff. But this was the requirement to interoperate. So our first idea was, let's just ignore all this complexity, and we'll use the wonderful tool Dialog provides to integrate with .NET. So, and we use, at the HTTP front end, we use IIS. So we built an integration server on Windows, which used IIS to expose an HTTP interface and calls, and we used the .NET framework to do all the SOAP stuff. And this worked pretty well. We've had some performance issues with the Dialog running under IIS, where performance would go down after a while, after we had served a certain amount of requests, so we had to recycle the IIS application pool and stuff like that. But overall, it worked reasonably well. But our main server is cross-platform, and our biggest customer runs it on AIX. So they had to have a separate server, and this caused some issues. Latency is worse because you have to talk to an additional server every time you do something related to web services, and it's more complicated because you have flow between different servers and different logs, and it's harder to debug. So when the time came to do SOAP integration in one of the core components of the main server, which is the interaction with the central census registry. So when you enter a search for a patient and the patient has visited the hospital before, it fetches the name and address and that sort of stuff from a central census. And that is very tight here. So we figured we'll try doing something else and doing this via the .NET server. And then the second attempt sort of to do SOAP was to write a program in C++, which used some C++ library. I can't remember the name of because it's in my files, which I don't have. And then just shell out that program, have that make the call, return the response, everything simple, and that worked pretty well for a while. It was C++, so it took longer to write. It was more complicated, but we wrote it as a sort of generic component that could make calls to any SOAP interface. So that was fine. And then one of our customers upgraded sort of something. And then because SOAP is so huge and so complicated, it no longer worked. So, so the .NET stuff always worked, at least if everyone else used .NET, which they mostly do in the enterprise, so that was sort of good. But then someone used Java, and then that sort of didn't really work. But okay, so the C++ solution then didn't work. And you figured, what do we do now? Okay, but maybe we can reuse the .NET stuff, but we skip IIS and all of that stuff. So we just call a .NET program on the main server, which for this particular customer who upgraded their infrastructure and then couldn't use their own solution, happened to use Windows. So we'll try just shelling out to a .NET program instead. We should probably just be able to write a PowerShell script to do this. And we did, and PowerShell is sort of horrible to write in, but it sort of worked. But that wasn't cross-platform. So then when the next customer came with different requirements and different interoperability requirements, of course, because it's SOAP, so it never works between two, unless everyone writes all the endpoints by themselves. It almost never works. We tried a cross-platform solution, so there was a pretty mature SOAP library for Python, and we know Python, and we have a couple of administration scripts written in Python, so we figured why not we'll hack together Python scripts. And there's a SOAP library called SOAPy for Python, so use that. And that worked for a while until that particular backend upgraded their SOAP infrastructure, and then it stopped working. Some obscure error related to OpenSSL and the order of ciphers, suits, and that sort of stuff. So finally we said, we give up with SOAP. Let's just treat SOAP like a really, really horrible REST service. So you connect over HTTP and you send some huge blob of XML, and you get a huge blob of XML back. And we just handle it case by case. We give up on SOAP. So the latest attempt is to use libcurl, which is an external HTTP service to send and receive request reply HTTP. And then we have just a huge template with pre-generated SOAP XML nonsense, which we fill in with the data in a couple of places, and then we send that. And the advantage of that is that curl is a very compatible library, so we don't have much HTTP-related issues, which we've had in all of the other, either performance-related or compatibility-related. And we'll see how that goes. It will probably mean it'll break whenever they do an upgrade, but it does anyway. So then we can just change the template around a bit. And we also don't have to do this whole, if you've ever handled SOAP web searches, they publish something called a WSDL file, which is a type definition of what they accept, and you're supposed to compile that file, which is lots of XML, into a DLL, which you load, which then provides types for, and all of this nonsense is completely necessary in a dynamically typed programming language anyway. So we can just skip that and go straight with it. So all of this story really is about the horrors of the simple object access protocol. I'm not sure what the morale is, what you should take home from this, other than that SOAP is very bad at interoperability and very complex. And I hope in the future that will lean more services will be exposed in a more simple way via HTTP. HTTP, which seems to be which generally works, unlike SOAP. And as long as you get, and most SOAP web services we consume, bizarrely anyway, don't use any of these objects and remote exceptions and having methods. They just return an XML string anyway. So all of this machinery is completely for naught. It just gets in the way of compatibility. So we'll keep the original solution, .NET solution via IIS, that's still present and still working. So that will be our main way of accepting SOAP connections from other services. And then we can tell our enterprise customers that just we use .NET, you love Microsoft, make it work with .NET, and we'll be fine. And they'll accept that. And tell systems to use some other incompatible way of talking SOAP to just man up and rewrite it in .NET. So that will be fine. And then the current plan is to expose more of our services more directly to avoid the horrors of SOAP and just use HTTP and JSON. So we'll do a really simple RPC interface over HTTP and JSON. And then that is in progress currently, and then we can build new clients and various integrations on top of this. And the enterprise, and for example, there are national standards in Sweden who dictate that you should use SOAP for various services and contracts, and we can expose those via the .NET stuff we already have, and then we can do our own, say, an API based on HTTP. And that's using Conga, and I'm not actually sure what HTTP library they're on now. I think they're using some very, very simple thing they hacked up themselves. But we'll see. Maybe we can use Rumba for that, or maybe we can offload most of the HTTP stuff to something external and just do the application logic in Dialog. And hopefully we can also, for calling out to web services ideas, we hope that we can use libcurl for that and just delete all the other weird approaches we have, like the C++ binary and the PowerShell script, Python script, and all the other various ways. So other than some slight performance issues, I'd say exposing via .NET and IIS is fine. It's worked pretty well. I think the issue with the threads accumulating and getting slow is solved now. I'm not sure. I'm not.
So was that an issue in .NET or in?
It was an issue in some sort of way with how our IIS interacted with Dialog. So we would start threads, and then they wouldn't be killed properly. So eventually, the Dialog interpreter would run slower and slower and slower until you did an IIS recycle, which basically tears down some shared structures and restarts them again. I think that's all by now.
I think
yeah. But that was one hair issue we had. And of course, there are always some type-related. We've had some type-related issues where how this expects an 64-bit int, and then we install a new version of Dialog, and the automatic type promotion doesn't recognize that it should be. We had some sort of issues, but not that bad. And hopefully, we can treat SOAP like when we do external calls, like just a really horrible HTTP service that's hugely complicated. Yeah.
Do you have any say in, the SOAP endpoints that you're talking about, do you have any influence in getting them changed?
In theory, but not in practice. It's hard. Most of the national standards in Sweden, they invite our customers to talk about how to expose a service or how to define a service. And sometimes we can talk to our customers and get input in that way, but it's very hard. The suppliers really aren't involved, which is strange, but that's the way it is. And we focus not on SOAP, but on changing that, because that's hard, but then we focus on the semantics of the service and what should the informatics content be, what sort of information should flow, and how should that be typed, and that sort of thing, because that's harder to solve anyway than the technical integration. So I'm not really sure, but how many people use SOAP web services? Is that And what do you use .NET or some of that? What do you use?
The one place that we do use it, we are not allowed to use .NET.
Okay.
So we flirted a bit with source and then wrote a simple, similar to what you said, still an APL, but build up the XML, run it through validations in development, and then just fingers crossed it'll run in production sort of thing.
Anyone else? Does anyone use source or?
We adapted the file. So
okay, yeah. So
implementing files.
Yeah, that's all I had really. Tale of the many horrors of SOAP compatibility. But I'm very curious into what others have used and what your experiences are. How does source, your hack version of source, how does that work well? Do you have compatibility or interoperability issues with other stacks? Or, no? Works fine.
Works fine. It's commercially working for at least a year.
The issues we had was the schema you referred to. The service provider didn't really bother to notify of any changes to the schema, and they had this very advanced delivery mechanism with 5 different phases, where each phase was on a separate server with a separate schema, and nobody knew when anything got propagated. So in trying to run something like that, it's very difficult to keep up and keep in line with what's actually on there. And what you said is what we've noticed as well, that in theory, it's self-defining and it's easy. All you need to do is compile this into a DLL. But you're not notified of a change.
No, exactly, yeah. That's our problem as well, that the WSDL files are updated, but they don't notify any of the systems integrated, and of course, it all falls down. Yeah, and also the fact that there is this hugely complicated type system enabling you to send type data, but everyone, well, I think virtually every service we talk to just sends XML. So it's all
for naught.
Yeah, it's all points.
Right.
But source is interesting. We haven't tried that, so maybe that would be better if we'd done source on the server. But then we'd have to do Kong externally, and we've had sort of we didn't want to complicate the server code by doing bidirectional communication from the same process, because we had a bunch of issues with sockets going strange. And now sort of we've finally reached a level where it's sort of smooth sailing. But this has been, I think, the first SOAP interface we did was almost 10 years ago. So this wasn't over the course of a year. We tried all of these different things, but very, very gradually.
Right. So you're hoping for, well, let me see if I can summarize. SOAP is slippery, should be put to rest.
Yes.
Do you agree with that?
Oh, yes. But it won't go away. And I think our plan is, like yours, is to, if we need cross-platform, just treat it like a really horrible HTTP-based service, and it will break anyway whenever someone does an upgrade. So there's no real loss. And for the exposing stuff, we'll fix the .NET license for them. We could try source, but then we'd have a whole shaking out period where we find issues or performance bugs, and it'll take a couple of years before it's smooth sailing. So I'm not sure it's worth it just to change, because it works reasonably well on .NET. And
Thank you.
Yeah. Any questions? All right.
Right. Thank you. Oh, about an hour, right?
Yeah.
Anyone that hasn't reported that they want to speak, that have changed their mind now and feel an urge to share their experiences with us, now is the time to speak up. And if not, I suggest a short break. And
I have a question.
yeah.
In my presentation, I was thinking I might actually do a little bit of a workshop thing where people try and install File Server 3 and do some RESTful web services. How many people would want to do that? Okay. Yeah. So I'll send the USB stick around a bit later. And just copy what's on it to your drive and pass it on. And then I'll explain. But I don't think we all want to download it from the internet at the same time.
Why not?
It's not all of us stuff. Okay. So we'll do that then. If I don't talk too much. Well, I have one. Oh, okay.
Right. Well, lunch is until 12.
So I will take the opportunity to either just flash out, talk about what your experiences are, or we will progress things and leave the workshop more time later, so to speak. So if you prefer, we could do another presentation now before lunch and free up some time in the afternoon. Or we could just mingle, but we don't have any coffee.
Well, that would be... Who's next? Stefan. Stefan's talk was an hour, right?
Yeah, Stefan didn't think he would need that much time, but huh?
Go now. I don't know.
Let's see. Stefan. Mr. Foster,
Yeah.
Would you like to do your presentation before lunch, or we'll squeeze you in now then? I think it's still recording.
Just leave it, that leave record. It was letting me recording a screen. But the way that we were doing it there. I think it should be.
Muted.
Yeah, we're seeing that.
Okay.
Should be.
Believe me, you don't want to see me first thing in the morning. Well, you have.
Yeah. Oh, we still have 5 minutes to go, right? I should wait until the appointed hour.
Is everyone here?
I think Lars popped out, didn't he? No, there he is. He's back. Oh, you looked at your, you looked at your watch and popped out. Yeah. So I suppose we can
I
start.
think it's just Gittens.
Oh, Gita's having a smoke.
So
She knows all this stuff, I guess. Probably seen this many times before.
I can hear her.
Var så där lite på sidan med... Nej, det var på det. Ja, jag börjar.
That's really nice logo, by the way.
No, Mike is a
Stunning. Mike is a
star.
Gita is
I think we can
Ja, det är bra. Det är sånt där jag har förstått det. Om du har lagt det. Så det ligger på skrivbordet, så skriver bara tilde slash skrivbord. Ja, tilde slash desktop slash desktop. Ska du hitta på engelska eller på svenska? Det går rätt. Ja. Jag kan prova båda då.
Okay, so I should start. And Brian is there. Brian,
Yes, I am.
you've noticed you're on up as the co-presenter.
Yes, I will do my best.
Because Brian wrote most of the software that you'll see and also prepared a lot of the demos and some of the slides. So just chip in whenever I say something that's not quite right.
Okay.
So we've seen some very interesting presentations this morning. Some of them using technology that Dialog, I think, is going to steal, like the Roomba stuff. And your experience, we're not that far ahead of, or in many cases, we're behind some of what you've seen here this morning. But we're trying to catch up and put it together in a way that's going to be easy for everybody to use. So you won't need to be a trailblazer like some of the people we've seen earlier today. And at the moment, we're basing it around my server. How many people here have tried using my server? Not that many. Okay. So I think my server has been growing for something like 10 years. It started out as a project that Stefano Lanzavecchia built. And then I noodled a bit more with it, but it was still very much a prototype until Brian came along. And in the last couple of years, it's been moving towards becoming really an industrial strength platform. I wouldn't say it's there yet. Somebody asked earlier about documentation. The documentation is still sketchy. But I think it is getting to the point where it's worth taking a look at. Maybe not before Christmas, but certainly just after Christmas. Even the less adventurous of you should be able to have a good experience playing with my server. So I think, especially since we have a little bit of time, I'm going to talk a little bit in general about what my server is, and then the real title of the talk about the RESTful web services. We'll try and do a little workshop at the end. How many people are going to try and do the workshop? Copy the files? Okay, quite a few. So hopefully you'll all be able to get a RESTful server up. So I'm going to talk a little bit about what my server is, and then REST, and you've already heard some of the reasons why you might want it, and we'll do the workshop. So what is my server? Well, primarily my server is a way of producing cross-platform user interfaces. That's really been the big motivation for doing the work, because Dialog users have had this QuadWC interface on Windows for what, 20-something years now? And the time has really come to move on. The Win32 APIs, you can still safely create a new application using that. We will be supporting the technology for ages yet. We'll have customers who won't be able to move off this for 15 years, and I think Microsoft will have to, at least on some platforms, continue to make the underlying Win32 API available. But if you're building a new application today, you really want to build it in a way where it could run on other platforms, on Linux, on Mac, on Windows systems, cut down Windows systems that don't have the Win32 API. Microsoft is starting to build server machines, and like they have a version for the Raspberry Pi, I think now, which doesn't have Win32 available. And we need a new technology for making user interfaces. So here's an example of a very, very simple form that you could create with QuadWC. I don't know how many people here have done QuadWC? Nearly everybody. So I don't really need to explain that. We've got a form, a label, an edit, and some output that we produce when you click on the button. And what we've been trying to refine this over and over again to get to the point where we had this keyword EWOC, which Gil mentioned, easy as QuadWC. And if you want to create the equivalent interface now on a web page, here's the code that you have to write. So you have exactly the same components. You need to add a form, give it a title, create. So the label that's one of the nice things, the label is actually attached to the edit field. So you have an edit field and you have a label which you can declare is linked to it. and then you have a button and a callback function. It looks very much the same as before. In fact, if we line them up here next to each other, it's like your Rosetta Stone. So creating the form, in nearly every case, the new code is in fact shorter, which is why I was saying it's easier now, we think, than QuadWC. Of course, you have a whole bunch of new controls to learn if you really want to take advantage of it. But if you just want to build something which is the same as before, I'll color all of these to link them together. The real big difference that you'll notice is that all the numbers have disappeared, right? Because all the new user interface mechanisms, whether you use WPF or HTML and so on, all of the alignment is generally done by using things called stack panels, where you put things next to each other, and then as the user resizes things, they're automatically moved around and adjusted. So the one thing that I guess is also a bit different is that where before we had a result, we had a text box which we changed the text property of. The common thing to do in when you're using HTML, these so-called AJAX style callbacks, is that you typically replace a named portion of the user interface. So we've got a div here. Let's see, where is it here? A division, an HTML division with the ID result. And in response to the callback to put this text up, we say, well, replace this div with a paragraph containing this text. But I mean, this has really been something where we've had, I don't know how many iterations, Brian, and had them shot down by Gita and other people internally.
A lot.
Sorry, a lot, yeah. Now we're feeling that we're really there. As far as easy as QuadWC is concerned, we are there. So if you want to get hold of it, if you haven't copied stuff off the USB that I sent around, there's a home page now, which is myserver.dialog.com, from where you can download it and see all the code samples. But we're running it as an open source project on GitHub. So let's see if I click on this. It'll take us to GitHub, and from there you can see all the change history. You can see files that have been changed and all the diffs, and you can contribute to the project. We'd very much like you to have that. We have 2 or 3 people now external to Dialog who are contributing to the project. We're really hoping that at least you will contribute code samples, and then maybe the more advanced of you will start contributing new widgets covering functionality that we're not covering yet. So let's actually, you can try and follow this. If you've unzipped the My Server part of it, but you can also just wait until we get to the time for the workshop. If you load the, shall I maybe increase the font size, or is it okay at the back? A little bit, is that okay? Okay.
It's fine over here.
It's fine over there. So the My Server, it's a workspace. You load it, and then you call the function start, and as the argument, you give simply a folder name that contains all the files. And by default, as part of the installation, you've got this thing called MS3, which is the same as, exactly the same as what's running on myserver.dialog.com. So whether you go to myserver.dialog.com or you install it, you start MS3 and you go to localhost and open what's on port 8080, you'll get the My Server self-documenting, we hope, more or less website. So there is some documentation. We've started, there's much better documentation than I think we had for 2.0, and the idea is that by around Christmas time, there'll really be sufficient documentation for anybody to use it. I think there's already enough for adventurous souls to use it. So there's various chapters that are here, currently just in the form of PDF files. There's a very small number of very simple applications that we've built. Whoops. Why is this not responding?
Is this not working in 14.1?
I think this should work in both 14.0 and 14.1. Are you having?
Yeah, we have a problem with the IBM 85.
IBM 85, Brian.
Yes, and should work.
Is the version that's? I mean, I've just given everybody a copy of the what's on in GitHub. You have
It should work under everything from 13.2 up.
It's not on 14.1.
It's not working on 14.1. Well, that's what I'm using. Is it classic or Unicode?
Unicode. 32 bits.
Okay, well, that's mysterious. We'll look at that when we get to the workshop part. The applications aren't coming up, which is more. Okay, idiom search. So we built a very little sample application where we've taken the SwedAPL idiom library and our own dialogue idioms. So I can search for my favorite is the two fighter aircraft flying past each other. So I can search for all the idioms that contain upgrade, downgrade. You see, there are actually 4. There's a kid's keyboard where if you're trying to teach a young kid Hebrew, you can use that. And there's a not very sophisticated tic-tac-toe game, but but then more importantly for you, if you're starting to, if you want to build your own applications, you're going to want to look in the controls section. So basically what we're trying to do now is the same as what we did for what John Daintree did for Quad WC, is he looked at the Win32 API and then he built a set of objects. I'm not sure how many we've ended up with in Dialog now, but it's probably about 100 of what WC-able objects. And we're trying to create a set of widgets that will be as easy to use as those. In the section dialog controls, if you expand that, you'll find the 25 or so things that we think are really the basic building blocks of applications. So a button, for example. If you select one of these, you get there's a little section up here which tells you, okay, it's the name of the control is dialog control button, what it's for. You click here, it'll take you to a documentation page. You can pop the sample out and run it as a separate page. You can ask to see a related sample, which uses buttons, so other samples which use this control. And then in here is the actual sample, so you can click on that. That's the test application. And then you can scroll down here and say you want to see the source code. And so this is the entire source code for the button sample. So it's a my page, which derives from the my page sample base class, which gives us all these icons and formatting. And then a my page has to have a compose function, which is called once when the page is loaded. And that's where you set up all your GUI. So we have a button with the caption press me, with the ID btn press me. And then we have a callback and an output div. And the callback function does this business of replacing the output. So it's using Ajax style postbacks. It's not posting the page back. It's just sending a message back, and then part of the screen is being updated. So at the moment we have about 20. We have all 25 of these dialog controls with samples. We look at the stack panel. So the stack panel is a way of aligning output in a web page. So here we have 3 controls that are aligned vertically. And down here we have the same controls arranged horizontally. And the way that's set up is we create a drop-down and a span containing some text and a button. And then we make a vertical stack panel, adding that array of objects. So you make a new instance of a stack panel with those 3 object as the argument. And then down here we add a horizontal stack panel with the same objects, and then we end up with the vertical stack panel and the horizontal stack panel. And this is sort of the general way you do your layout. So if we look at the related sample, the advanced stack panel, go to see that page, that's showing a bunch of nested stack panels. So we've got a horizontal stack panel with 3 vertical stack panels inside, and then these objects that just automatically become aligned under each other with various types of margins, padding, no padding here, some padding there, margins and so on. So that's basically how you control the layout of these pages. Then in addition to the dialog controls, as you may know, we have this agreement with a company called Syncfusion, who make third-party controls for a wide variety of platforms. And Dialog has an agreement with Syncfusion to bundle their set of WPF controls. If you're using .NET to build desktop applications, you've got 120 or something controls to choose from. And then they have a JavaScript library also with about, I think now, about 100 controls. And we've started building APL covers for those. So if you take their accordion control, for example, so an accordion is something where you can have multiple sections and you can open them one by one. We've tried to do a John Daintree on this and build an object called an SFEJ accordion, which is, so we add an accordion with the ID of AC. We set its titles property. Then we create 2 paragraphs, and we say the sections property of it is P1 and P2. And then as a result of having added that to the My page, all of the HTML and JavaScript that's required for these to appear is automatically generated when the page is output. Yep. And so I won't show you any more of those. You have the whole thing. What's really exciting about this in the longer term, let's see, where did we get to, is that this isn't merely a technology that's useful in this structure that we've seen here, where you have some dialog process running. It's running my server. It might be running your own. I mean, we have a number of customers, I mean, like Gill, who not really using the My server to generate the UI. They're generating Flash, JavaScript, all sorts of other ways to generate the content. And then it's going over the internet and a web browser is rendering it. What we think is a likely way to build applications in the future is that you might jam all of that stuff together on a single machine, which could be Windows, Unix, Mac, Android, Universal Windows, iPhone even. And instead of having the internet in between here, you have an HTML rendering engine that you can just load as a DLL or something like that. But you can have the same interaction going on. So you generate HTML, JavaScript, push it into here. It does whatever it needs to. When the user presses a button, drags something, whatever, you get the same message coming back, an HTTP, maybe a WebSocket thing, maybe a post. But your application logic is exactly the same, whether you're running a web server or you're running a desktop application. And the JavaScript widgets, the things you can embed here, are becoming so good that you can really give the user the same user experience that they're getting today with desktop widgets. So although you think of HTML as a web technology, in the future, I think we're going to see this kind of thing. So at the moment, we're playing with something called the Chromium Embedded Framework. And I can just, let's see, no, I don't want to shut that one down. I'm going to use it. Start a new APL session. So this is just a little workspace we've been playing with. So there's a function here called OpenURL, which takes a URL, the tic-tac-toe page, and a window size and position. And when I run that, I get essentially the same thing as if I had a web browser, except it's inside a normal desktop window. And we're going to, if we can get this to work, we're going to enhance it so that you can take control over all of the Chrome and have menus and stuff under the control of your code. And then we'll have the holy grail of a new way of writing applications that will run anywhere. Same user interface technology. And we'll have the replacement for Quad WC for the next 25 years, however long this lasts. The final thing I want to show you about this My Server is something that I blogged about recently. You already have seen this. So I've got a My Server running in the background, and I've loaded another My Server workspace. But instead of starting MS3, I'm going to ask to test MS3. And we've built a mechanism for automating tests, where I'm just going to change this so that after each test delays for, let's say, 2 seconds before moving on to the next one. And then run it. So what this does is it uses something called Selenium, which is sort of the industry standard web automation technology. It starts an instance of Chrome, and then it's now going through the test suite, running each one of those applications, pressing some buttons, typing something into it, verifying that the expected output is appearing. So this is the button, the data list, edit field, field set, which is a collection of fields. This is just an image, I think. Font awesome. Form. Oh, this is if you have an accelerometer in your device. Input grid. I think that was a calendar it was testing there. Various types of validation of numeric input, passwords, rankings. Oh, we've still got some tests that fail. Drag and drop. Selection. Radio buttons. I'm sort of allowing this to run a bit slowly now so you can get a feel for what's in here. Multi-select lists, drop-downs, stack panel advanced.
So this Selenium is the framework for writing test cases for web.
Yeah, it's sort of become the industry standard. It's being supported by all the various web browser makers as well. Google is one of the big people behind this. And it's a very, very simple API where you can basically, because you saw in all the examples that when you create a user interface element, you can give it an ID or a class name or something. The API for this is, well, go and find the thing that has this ID or this class name, type this into it, move the mouse 10 pixels down inside this element, press the button, tell me what's in the text property of this element, and so on. You can access the whole DOM under program control very, very easily. At the moment, we only have it working on Windows because we're using the .NET covers for Selenium. But we're hoping we can find, because the Dialog APL has a much better .NET interface than it has to any other kind of object framework. We don't have a Java interface. Hopefully we can find a way to drive it perhaps via Python or something like that. What happened?
Sounded like fire alarm.
Yeah, looks like the projector.
Did the projector reset itself?
You're still online. Do we need a fire alarm for that?
Should say fire!
Yeah, blue screen.
Oh, I think I know what happened. I think I know what happened. We must have lost power or something briefly. And then my laptop decided it wasn't there.
Just reselected the HDMI.
If you try disconnecting it.
Physically disconnecting it.
Yeah, to see if it kicks back to life.
Right, you still there?
I'm here. I'm here.
Your PC ran into a problem and needs to Start. We're just collecting some error info, and then we'll restart for you. 10% complete. Okay, so, where's the copy? Questions on this? Because I mean, we're done now, sort of with the basic MyServer introduction, and move on to the web services part of it. I think after this. But what we imagine in the future is that something like this Chromium embedded framework, Dialog will find to embed that either directly with the interpreter, or we'll build a DLL based on it that you can load and start building applications. Whether you use MyServer or some other way of generating the HTML, you'll be able to use this. Well, our goal is, this is still a research project, that you'll be able to inject HTML, JavaScript into it and get all the callbacks back. My own long-term vision for it, if we can do it, is that you'll also be able to run server-side processes on AIX or a Linux server, generate the HTML, get it tunneled down through to something like our RIDE, and have it generated. So you'll be able to, it'll be just like the mainframe in the good old days, that you'll be able to run mainframe applications that are running logged in under your user ID on a mainframe Unix machine, and have it generating HTML that you can view on an Android phone or an iPhone or whatever, without using IIS or Apache or something like that. Right now, there might be very good reasons for using Apache, denial of service attacks and security, your corporate load balancing, etc., etc. But if you're just building a single user application, you'll be able to use this kind of technology for that.
I just wanted to inform you that the reason for this little signal was that someone attempted to cook in their flat and apparently set off the fire alarm. So,
What do you mean? If you live here, you're not allowed to cook anything.
No, you have to go to the restaurant.
Yeah.
It's triggered the generator for some reason. So she will let us know if we have to evacuate.
Get ready.
Where's the exit?
And by the way, the window is open 10 centimeters, I've been informed. Oh, also, they said you'd have to take the stairs.
It's hard to squeeze.
Okay. So let's see if we can. But any questions on the UI side of MyServer? I mean, clearly it needs more documentation. It needs more samples. I mean, that's something where you can really help us, is build some interesting applications.
Lost network access.
Sorry?
You haven't got access to the network.
I haven't got access to the network.
Yeah, I will be surprised if Brian is still there.
Brian, are you still there?
I am still here.
It's a miracle. We sort of lost power on various things here, and my machine crashed, and we're just coming back. So what do I need to do now to...
It's interesting, he wasn't even connected. Right? Maybe it was the HDMI that he said.
I need to go back to...
Can I ask a question?
Yep.
I can't see anything. Is this normal?
Sorry.
I have no picture.
Have you... can you see anything else in the room that you're in?
Oh, good point. Let me turn on the lights for a sec. No, I don't. I can hear you well. I just can't see.
At the moment, I'm not projecting anything because I lost the connection. Somebody needs to make me the presenter.
Yeah,
again.
on it. Just trying to figure out which one of you two is online. Okay.
Yeah, that could be the reason then.
Everyone has done it.
I am the presenter.
Okay, now I see something. Okay, got it.
Okay, so let's see. Where were we at? We were here. Okay, so essentially, I mean, maybe not MyServer, but certainly this idea of generating HTML5 and JavaScript we currently think at Dialog that that is, you might as well get used to it. That's the user interface technology that will be current for the next 15 years. What do you say, Sava? 10 or 15 years, HTML, JavaScript. How long will it be with us?
Forever.
Forever. 20, okay. So, as good as Win32. It's the next Win32, I think, if you're thinking about building new applications. Okay, so what is my server? Well, the most important thing, at least when we started, was this idea of it being a set of cross-platform GUI controls. So it generates HTML5 JavaScript, and you should be able to render that on any platform. But of course, there are lots of people who prefer not to build their user interface in APL. I mean, there can be very good reasons for that. You might have a bunch of people who are very, very good at that. You might think that your chief actuary has better things to do than design user interfaces, and so on and so forth. So we think that as important as it is to give you tools to generate cross-platform GUI, because there will be people who need to do it all in APL, at least in the prototyping stage of an application, it is equally important to start to really make it sort of an industrial strength component of Dialog APL to deliver web services. Right, that's that bullet point there. And that's where something we've been looking at for, I think, what is it, Brian? 7 years. Let me get back to my server status in a bit.
Yeah, about that.
It's about 7 years, and we, like some of the presentations you saw earlier today, we looked at SOAP. So, as Joachim explained, there is something called Simple Access Protocol, and we could laugh. Then they officially changed that, so it just stood for SOAP. But that wasn't good enough. It's now actually disappearing, I think. SOAP is going to, again, it's one of these technologies that has so many tentacles out there in systems and official standards and requirements and so on that it's not going to go away immediately. So you will need probably to continue to be able to at least call SOAP services and maybe also provide them. It was XML based, and to make a function call you would have all these headers and things that Joachim was talking about. The complexity of making a function call requires huge quantities of XML, particularly, but this is actually one of the nice things about SOAP in a way, is that standard had something called Web Service Description Language, where any system that offered itself up as a web service had to provide this WSDL web document, which said, well, I have, for example, I have a function called regression, and it takes as input these things which have this name, occur a minimum of once, maximum of once. It's a string, this one is an integer, and then you declare the type of result that you would get back from it. And what the C# people and the Java people and everybody else did was they built automatic code generators that would take a document like this and generate a C# class or a Java class, where the application programmer would just make an instance of that class and it would connect to the web service, and then they could make function calls for these types without really having to know anything about the underlying machinery. So the fact that the web service described itself in this way made it very, very easy to use, at least in the first instance. And then, as Joachim says, then they change the specification and your C# program stops working and you don't know when to recompile it, and so on and so forth. So in theory, it's great. In practice, all this SOAP stuff is just, it seems to be too heavy, and people are now moving away from it. But Dialog, 7 years ago, I think it was, we built this thing we called the Standalone Web Service Framework, which is what Stefan was using for his first application. We called it Standalone Web Service Framework because it allowed you from APL, without IIS, Apache, or any other infrastructure, to build a very little web service that could provide the WSDL. So you would have your APL functions, and then you would do a little bit of work to describe them in the same way as if you were, I don't know if any of you built OLE servers. You basically had a way of saying, well, I have this function and it has these arguments and I have these types, and then SOARs would generate those massive XML documents, and the C# programmers and whoever wanted to use them would be happy. And we've seen some people use that very successfully. But this isn't something, unless we have people come to us now and say, we really need more features, we're only supporting SOAP 1.1 and so on. We don't really see that we're going to spend a lot more time developing this technology. We think REST is where people want to go. What we are going to do, though, is probably get rid of SOARs as a standalone thing and roll it into my server, or at least give you the ability to do that, though we may rethink this because this Roomba work that has been done is really, as far as we can see, quite excellent. Well, as one would expect from Paul's hand. And he has done a lot of work to support HTTP protocols. And we may decide quite soon to use that as the basis for our tools like SOARs and my server. And then maybe there's a good case for keeping a very, very small SOARs built on top of Roomba, so that the people who want to use SOAP don't have to install the full my server framework to get that. But anyway, this talk is really about REST. And finally, we're getting to REST. So, you can do research on what REST stands for, and it will tell you that it stands for representational state transfer, which isn't a phrase, Brian, that means anything to me. How would you explain that? Representational state transfer, what's that?
Basically, things are represented as resources, and you use the verbs to move things back and forth and change things.
Yeah. Okay.
But that's the best I can come up with. It's an amorphous term to me too.
Yeah. In reality, it's like NoSQL. It's one of these terms. Really, it's not SOAP. It's sort of any other kind of web service where you're just doing simple HTTP transactions and you're transmitting a data payload, which originally when people were just moving away from SOAP, all the payloads were in XML. But now, as this JSON format, which is much more human readable, we'll see some of it in a moment if you haven't seen it before. JSON is taking over as sort of the data representation that everything on the web uses. So the WebSocket stuff we saw earlier was using these JSON messages to send data back and forth. The modern web services tend to use JSON. Dialog has just added I-beams to convert easily between JSON and APL arrays, the same way we had Quad XML, or have Quad XML. And as Brian was saying, so this representational state transfer is about that you have these 6 verbs. So you get a resource, you add a new one, you replace, you delete. Head is a bit odd. That's the question about whether something exists, right, Brian?
Yes.
So a slightly strange name. And then you can ask for options. And then you identify the data in your application. You try and map the data structure that you have in your application into the URI. So rather than the URL being the name of a specific file that you're asking the web server for, it's a logical selection of data inside your application. So this would be the data for customer 123. And so here's an example. I don't know if that's readable at the back, but here's a very simple example of this is included on the USB that you have. So if you want to make a web page which is a service rather than something that renders HTML, instead of the compose function, you have a respond function. And it basically needs to, by default, it needs to return a namespace which contains some variables, which we will convert into JSON and send back as the payload for it. So this is an application that can either take a principal, a rate, and a term and calculate the payment, or it can take a rate, a term, and a payment and tell you what principal you can afford. And here's the actual application. There's these two lines of code doing the computation one way or the other. And then the code here is saying, well, get me the input parameters, print, rate, term, and payment. And then it checks to see which ones of them are empty. It validates that exactly one of them is missing. And then if it's the first one that's missing, if it's the principal, it computes the principal. And if it's the fourth one that's missing, it computes that. Otherwise, it just returns this message that says, provide one of these sets of parameters. And the way you would call that, well, actually, why don't we just switch to doing it live rather than showing slides. So this you should all be able to follow. If you've unzipped the My server into some folder, then I'll explain each one of these steps to you as we go. So you need to load the My server workspace from wherever you installed it. Right? I have it in C devt My server. You need to remember where you installed it. Type that. And then don't start MS3, which is the demo application, but set this variable site. So you could also run this demo. The demo file is also included on the zip. So if you want to save the typing, all know how to run demo. So it's a user command. It takes the name of a text file containing a sequence of pre-entered APL expressions, and then you type Alt-N for next to call up the next line. You want to take a split? Is everybody?
I'm doing something else.
You're doing something else? Okay. So do people, who wants another second to try and get demo working, or nobody? So I'll just carry on, and you'll catch up if you can. So the second zip file that was on there was this folder called RESTful, which I've put in the dev RESTful. And then what we'll do, so what's in there is, so a My site is typically just a folder. In here we have, you put all the application code that you want automatically loaded into the workspace when your application starts, into this folder called into the folder called code. Then when you start the My server, all of that stuff is loaded into the workspace. And this file here with the cryptic name BL is actually our business logic. And it has an initialization function that creates some customers, products, orders, and details, as you would expect. And then it has functions to add a customer, get a customer, update a customer, delete a customer, and so on and so forth. I'm not going to look at that in detail now. It has a cover class for the My server where you can have one of these override methods that Gil showed us right at the beginning of the day, where if you override on server start, you can put in some code that gets run when the My server site is started. So we call BL init, which initializes our database in here. In the configuration, you need, if you want to run a RESTful site, you have to make a couple of, make sure you have a couple of settings in your configuration. In this case, we've needed the class name so that we could tell it which is the class that implements our server, so that that initialization code gets run. We've set RESTful to 1. Basically, setting something setting RESTful to 1 means that when my server goes to look for a URI, instead of interpreting everything as a file name that it tries to go to, it interprets everything, Brian, is it correct? Everything except the last segment?
Well, everything except for the first segment is treated as the page name, and then everything else is a parameter to that.
Okay. So only the first segment is the page name, which loads some code, and then the rest of it is interpreted by your code. Did we just lose somebody?
We just got Fiona.
We got Fiona. Excellent. And then you have to make the list of the HTTP commands that you intend to support in your REST server. What is the default, Brian? Is it just get or?
Well, my server itself started out with just get and post.
Get and post, yeah.
Yep.
So you can have those. If you don't want to support the others, you can have them turned away at the pass by my server. Okay. So now I think we are ready to start the site. And so in Dialog APL 14.1, we have these I-beams for converting from APL arrays to JSON and back, and they're still just I-beam. I think it'll probably be another release or two before we turn them into a system function. These will eventually become some kind of quad JSON function. But actually, before we use our own web service, I'd forgotten, I put in a little example here of showing how to call one of the many public web services that are out there. So this is one that Brian has found, which is the US Weather Service, which has a web service where you can give it a zip code and you can say what sort of data format you want. And then we provide a function where you can have one of these verbs as the left argument, and then the URL and the parameters on the web service. Brian has looked it up. We can get the data back, and I'm passing it. This is an old style web service which returns XML data. So this thing returns a huge amount of data from the meteorological department, where we have some timestamps and we have some daily maximum, minimum temperature, probability, precipitation, and so on. So you can find these things on the internet. Some of them you have to pay for, others are free. Now, if this code that we looked at a moment ago, the mortgage web service, actually using WS as an abbreviation when writing these things is pretty confusing, right? Is that a workspace, a web service, a web socket? I keep getting confused, but this is the mortgage web service. And I just called it and I gave it no parameters. So of course it got annoyed at me and it just gave me this piece of JSON back saying, so this is the first element of the get is the return code. 0 means that from an HTTP point of view, this worked fine. We get some headers back, which tell us.
Actually, the zero is Conga thought it was fine. The headers, the HTTP return code, the 200 means HTTP thought it was fine.
You're right, yeah. This is the HTTP return code where 200 means it was fine. This is the Conga return code which says that at the TCP level everything worked fine. And then the third element is the data that came back, yeah, which is this JSON. So the message is an error message, and then there's an empty payment array, principal array, and a rate array. If we call it and give it some input parameters, then it picked up the principal, the rate, and the term, and it returned JSON where the message is empty, which is our indication that from our application point of view, everything was okay, and it's computed the payment and returned that to us. And the way you use this from JSON IBeam, the default, actually it's probably not the default, is it? In this case, we set from JSON to be a left argument of 0, 1. I can't remember what the 1 is, but the 1 says take the JSON and turn it into a namespace. So in this last example here, we can say from JSON, the 3 pick, so get the JSON coming back from it, and then .pmt gives us this number that came back in the JSON. Yep. So there we're calling our... Right, so we looked at simple sample server before, just to show that it has that initialization logic. The My Server page that implements this, which uses the business logic, is again a class that derives from RESTful. That means that it has access to some properties that are exposed by the RESTful base class, the most important one being the command. So when by the time our respond function is called, the base class has taken all the incoming HTTP requests apart, and it tells us what the command is, so we can select and decide whether to do a get, put, and so on. And it also populated another parameter called underbar URI, which contains all the data segments from that. So the add let's see. Right, okay, but in this case, we're not actually using the URI to get the name, for example. We're using the get function. So the get function, which is in My Server, which can be used both in a web service and in a web server page, will get the value of an incoming parameter. Whether it came on the command line using these notation with the question mark and the ampersand, whether it was included in the URL, or whether there was actually a post back and there was form content where there was a field in the form called name and there was a value. Inside your code, if you say get name, that will give you the value of name that was passed back from the browser, regardless of what the mechanism was for doing that. And this is sort of the part where we're still not quite happy, because if you compare to Core WC, you would be sort of making a direct variable reference to data that was automatically bound. As the user types, the value of a variable is changing. And that's what we'd like to get right in the next version of My Server. Do data binding of the nature that you were playing with, Gil, in your example, so that we'll be able to do data binding between your variables in some namespace. You'll declare that this namespace binds to some Angular JS structure or something like that. And then we'll also need WebSocket support for that, of course. Build it into My Server. And then you'll be able to make changes in the server code and push them down to the client at any time. And also any changes made by the user in the user interface will just come back without necessarily having post events and so on that you have to sort of generate at a higher level. But for web services, I guess that's irrelevant. You wouldn't be using data binding there because they really are RPC calls at the end of the day. So this customer example is also there, and that's, I think, Brian, this is complete, right? You implement every single one of the verbs.
That's correct.
On this data structure. So we can add, delete, and so on. And in each case, what's in this class is really just selecting, getting the data that's required as the arguments, and then inside each one of these functions, there's a call to the business logic function get customer, which actually goes and looks at that data structure that was populated by the init function.
Yeah, the idea behind this was to show an example of grafting a RESTful interface to an existing application.
To an existing well-structured application, which had a nice API.
Yes. There are so many of those floating out there.
Yeah, there are so many of those out there. So this should be very, very easy. So there's a function in here called show, which shows us what's in this database. Unfortunately, not designed for a very, very small screen, but I mean, this is, you know, another one of those order details, products, applications. We've looked at that. Okay. Yeah, this is a problem that we've been struggling with in Conga. So this is really an aside for those of you who've been using Conga for a while. The problem here is that IPv6 support has been very slowly making its way out into the world. And initially we had the problem where if the server didn't specify whether it wanted to use IPv6 or IPv4, it would ask Windows which was available, and if Windows said IP6 was available, it would bind to that, but then there'd be a whole bunch of cases where that just didn't work. So in all of our samples, I think the My server, if you don't change the configuration, a My server will start using IPv4 only as the default. It's easy to change in the configuration. But my laptop, when the client asks whether IPv4 or IPv6 is available, it's told that IPv6 is available, and it tries that first, because when it asks what's localhost, I think the first address that it gets back is an IPv6 address. And then suddenly you get, well, I can't connect to localhost. Come on, you must be kidding. And the solution to that is to tell Conga to use IPv4, in this case at least. Then you have to go back and do it again. Oops. Right, so we said go and get customer, and but the verb was options, right? So we said go to the customer web service and ask for the options, and Brian has very kindly given us this nice text output then, which says, well, this is how you use this web service. So you don't have the WSDL, but the nice thing to do would be to, for the option command, output something like this so that people can understand how they should use your web service. There are standards. I don't know, Brian, if you've looked at any of them, but there are standards for RESTful web service description language, but I think the problem is there are 4 or 5 different standards.
Yeah, WADL seems to, WADL seems to be the predominant one that I've seen.
Okay. But I don't know, I mean, Joachim, have you looked at that? Have you looked at REST at all?
Yes, we've looked at REST for the new interface I talked about at the end.
Yeah.
And I think the original idea of REST is that it's supposed to be like hypertext, so you're supposed to get links in the initial reply you get back, and then you can follow those links to get more information.
Yeah, and I think Brian has even done that. We'll see that in a second.
Okay, yeah. But otherwise, there are some...
but what about
we haven't looked at those like WADL and that sort of stuff.
Yeah.
Our current idea is to map our existing API, which is exposed via Conga and APL command mode, fairly closely, but rename stuff so that we don't have to maintain 2 different...
Because, I mean, I could be wrong about this, but I get the impression that JSON, I mean, JSON is coming out of JavaScript, right? It stands for JavaScript Object Notation. And the people who like JSON are the people who are using dynamic languages. I mean, JavaScript is identical to APL in that respect, that it says a number is a number. There are only 2 types, right? There's text and numbers and objects. So it's coming out of a dynamic language tradition where you don't declare types that in that much detail. So it's much more APL-like, much more APL-friendly way of doing things. Okay, so if we get customer, then we get back the return code, we get back some headers, and we get back the data, which is one of these JSON things. And if we pass that through from JSON, we get back an array of JSON objects, because you can see the curly brackets. There's one here, that's an object which has some properties. But that's an array of customers. So if this is a vector, and if we go into each item and we say, get me the customer ID, the customer name, and the customer URI, then Brian has done exactly what he's supposed to be doing, and he returns a URI for that customer that you could then follow and go and oh, okay, so to JSON, just pretty printing it. It's not. If you turn it back into JSON with the options that we've got there, it formats it nicely. So we can then go and get an individual customer. The format JSON function that we set up before just converts to JSON and back. So it just pretty prints it, so we don't get that long string that's very difficult to read. We can go and get the orders for a customer. Yeah, I mean, this is fairly obvious what's happening here. Get an individual order back, order number 9, and so on and so forth. Get a non-existent customer, you get an error message back. 404 not found is how you're supposed to handle that. Insert a new customer, so do a post, and the parameters. Update a customer using the put command, changing the name. And we can see now that customer number 400 is now called Dan. Can't remember what he was called before.
Daniel.
Daniel. Ah, right. There we go. Daniel has been renamed to Dan. And we can delete a customer. And we can see that we got the confirmation there that it was okay. And is this a norm, Brian, that when you delete something, you give back the data for that customer, or is that just your choice?
That was my choice.
Yeah. So that's not a standard. And verify that he's gone. Yeah. Let's see, what was I can't remember what this was about. Okay, there's a function in here called getQuote. No, this is never mind that example. Just another example which you can look at in there of getting. I think that's actually just getting some JSON data from a website that isn't really a web service. It's just a website where if you go to URL with some input parameters, it gives you some JSON. But I mean, when is something a web service and when isn't it, right? I mean, if you say get with the URL and you get some JSON back and it contains the data that you want, then it's a web service, right?
Is that the definition?
Well, Brian found. Let's see, where did we have that somewhere here? Brian found this in some government glossary somewhere, which just says automated information services over the internet using standardized technologies and formats protocols that simplify the exchange and integration of data over the internet. Then it's a web service. If it does that, it's a web service. So let's see. We looked at all this. We saw these verbs. We talked about all of these. I think so the first two are general, whether you're building a web page or a web service. You have these page data, which contains a namespace containing data. that you can retrieve with this get function. You've got the command, so you can see which HTTP command was used to retrieve the page, and then if it's a RESTful, if it derives from the RESTful base class, then it also has this URI thing. So Brian, the RESTful class, essentially what it does is it adds this URI, and then it has the automatic formatting of the result as JSON. What else does it do?
Yes.
Is that sort of basically what it does that's different from what a web server page would do?
It exposes a couple of methods to make it easier. For instance, if you notice, the options verb returns text as opposed to JSON. So we expose a couple of methods to make it easier to do things like change your content type, set headers, things that you'd be more likely to do in a web service environment than in the typical MyPage environment.
Yeah, we talked about the configuration. At the moment, you have to go into the configuration for your site. And as it says here, we really recommend that you do this in the server XML file for your site. There's a server XML file for the My Server installation. And then for each one of your site folders, there's another one. And we really recommend that you add this RESTful command at the site level rather than setting your entire My Server installation to be RESTful. But we're also, the RESTful stuff is really quite new, and we're still wondering actually whether we need this configuration parameter. We might be able to say something that, well, if you give a URL like this, there isn't a file called that, then have a look to see whether there's something called person that derives from the RESTful base class. And then that particular page is then just a RESTful web service, rather than having to set RESTful for the whole site. That would allow you to more easily integrate, have a site that has some pages and some...
I was going to say my little fork there, I changed it from a flag to actually naming the pages that I wanted to act as RESTful handlers.
Naming them differently. Actually, no, Brian, that's not a bad idea, is it?
Rather than setting RESTful, to have a REST parameter that names the pages that you want to act as RESTful handlers.
Yeah. Actually, this is something you may not have seen yet, that we've changed the extension for My Server pages so that it's no longer .dialog. In the last week or so of commits, it's now .mypage, and I guess it might make sense to have a .restful or .myrest or something like that. Yeah. Okay, so I think we've said all these things, except a couple of things. At the bottom here. So REST is supposed to be stateless. Though, of course, exactly what that means isn't clear. Of course, if you have parameters, session parameters that identify you, then, of course, your server can implement any kind of state that you want. But you need to be... you can use cookies, right, Brian, with...
Yes. Mostly what I've seen in my research is that suppose you run a query that would generate a list of, a few thousand items, and it gives them back to you 10 at a time, or 100 at a time. You wouldn't, if you were to have implement a command that says, give me the next chunk, that would violate REST's stateless goal. So you actually need to provide, give it a URL that points to that next chunk, not give it a command that says give me the next chunk.
Okay, so you would need to have a URI that said, somehow give me records number 11 to 20. Somehow included in the URI, and then okay. And then there's I mean, we could have a discussion about this now. Stefan's question about authentication. So if you want to have user authentication of either web services or web pages, I think my server implements the sort of very simple, very primitive, is it based on plain text, user ID and password, Brian? I don't remember. The simple authentication, which is something that you might use just for a demo, but you wouldn't really want to use in a production system. The state-of-the-art solution would be using things like integrated Windows authentication. If you have a Windows domain server, you could somehow, I mean, Conga has calls which would allow the server side to have a short conversation with your client to establish the identity of who's at the other end. But how you would do that over HTTP, I'm not sure. Would you need WebSockets, Björn, to be able to do that?
Yeah.
If we had WebSockets, then we'd be able to implement that. The state-of-the-art solution is probably to issue certificates to your users if you can get your IT organization to do that. But we haven't met, well, we have one customer who's implementing that at the moment, right?
Yeah.
Other organizations, you talk to them about, say, well, you know, you should issue certificates to all your users, and they'll say, yes, we know that, but we're not ready to do that yet. Still, how many people here have, you know, corporate certificates? One. Yeah. So everybody knows that that's where they should be going, but nobody's really been able to get their act together to do that. I don't know, Stefan, is that something that you might be able, you think your IT department is ready to do, at least for 5 users? Because it's like a pretty big administrative hassle to set that up. You have to get registered as a certificate authority. And
you don't have to do that. You can have self-certified certificate.
Yeah, okay, you don't have to do that.
And you can use that in front system.
Yeah.
Because that's where they said like for each machine has its own certificate. So this is not the users, but machines.
Right, yeah. I mean, Björn has done some work with self-signed certificates. So if you think you'd like to do that, if you'd like to set up a small application and generate your own certificates, it's not very difficult to do that, right? You can quite easily do that. And Conga and my server support secure sockets. So you could take a certificate and put it on each of the client machines. And when you make your web service connections, you can have a secure socket created where the information about that certificate is given to the server. It can be 100% sure that it's, you know, it's cryptographically proven that that's that machine. If it's just a certificate that doesn't prove who is sitting at the machine, then you need a certificate which is integrated in such a way that before the certificate can be activated, the user has to type in a PIN or has some kind of physical token to activate it. But again, those devices are becoming quite common, right? Björn, you said you found one on the internet yesterday that cost like 20 euros or 25 euros. So you can have a device that has the certificates on. The user plugs it into a USB port. They have to type something, right? PIN code to activate it. And then I think you have a pretty secure system, though Sava is dying to tell us something about it.
Like you can have, when you call certificates, you can have some like certificates with a PIN all the time.
Yeah.
You can have like a kind of feeder, I think. And use, for example, for Chrome. And you could have something, I think 6 euros is the cheapest one that you plug in USB. And okay, you have to activate. This is only without the PIN. 25 is the that you have to type. Also.
With a PIN, yeah.
Yeah, I think you have
of course, if you're using Windows, you can have certificates that are in secure storage that is only available to the user when the user is logged in. So you say if you can trust your users to log in and not leave their terminals unattended, then you know they have logged into the Windows machine. But I think for really secure applications, you are going to want a physical device. Yeah. Yep. So to conclude, it's an open source project. This is a sort of general thing we're trying to do now with all of the new tools that Dialog builds. We're putting them up as open source projects on GitHub. So although we can't open source the APL interpreter yet, we're trying to open source all of the APL code, all of the new APL code that we're writing, so that you can inspect it and at least, maybe you will contribute it. We have one user. I would like to publicly recognize Michael Bass. He has actually written a couple of the widgets that you can use already. The font awesome stuff is his work, and a couple of other things. And we can see that there are people, he wanted that for his own application. He's building an application in my server, and we can see that we're starting to get some of this synergy that has been missing from the APL community in the past. So please, at least feed back to us whether you like it or not. Build some sample applications and put them up there. Also important to say that a very, very important thing for Dialog now is, we added support for Mac OS X. We can see Android support in the future. We're not ready to put dates on any of these yet because we don't think they're urgent. But within the next few years, we want to have Dialog APL available on all the platforms that are likely to become important eventually. And all of the tools that we build, things like MyServer, the cryptographic work that we do, we try and implement it, if at all possible, so that it works identically on all the platforms. So the next couple of things that are related to this that we're thinking seriously about now is using Roomba, because we think it looks really good. So throw away the lower levels of MyServer and get some of the benefits of HTTP 2.0 and other stuff that's been implemented there. Data binding, is it Angular that's the hot up and coming thing now, or is it already peaked and we should looking to the next
I don't know. I'm judging, but
these technologies come and go so fast. It's quite scary.
I think Angular is not the hot and up and coming. That's React.
React.
Yeah,
Is it better?
Angular has recently come up with version 2, which is a good sign of it.
2.0, that's where these frameworks start to fade, isn't
exactly.
it? And they're already
so
time to move on.
Well.
I think
Sorry? Brian? 2 years ago it was Knockout, then Angular, and now React. Okay, so
yeah. But whatever we do at Dialog, we'll be trying to hide that, so that. But I guess that's not really possible. Or maybe it is. Yeah, if we're generating the JavaScript, we can maybe hide it from you completely. We're in control of both ends of this. And then at the Conga level, try and actually take away some of the stuff that's in Roomba that's been really hard work for Paul to do, and where he can't really get the same performance in APL as if we were to pull that down into the C layer. So the WebSocket support, and then actually putting support for HTTP commands into Conga, so that you don't have, at the moment, if you look inside the Conga APL code, it's looping around on if HTTP GET, we have a function. It's looping around looking at the HTML that's coming in to try and decide whether you've reached the end of an HTTP command. And the support for secure features, support for certificate stores and so on. The underlying, we've had support for that for what, again, 3, 4 years? 5 years, probably.
A while.
Yeah, a while. Very few people have actually been using it. But we think that's going to change very soon. I think that the requirement for you to write secure applications is about to break loose. Fortunately, the tool layers that Björn builds upon are also much improved now. And we'll be putting some of that into Conga. So, I managed to use up half of the extra time that we had.
Well done.
Unless there are lots of questions remaining.
Well, I got one comment from Paul Mansur saying there are HTTP range requests in the headers. You can specify a range to retrieve. So he hasn't got that much more to say about it. But
as part of REST or HTTP?
As part of the HTTP layer. So
in 2.0?
No, in 1.1.
In 1.1. Okay. Yeah. Well,
that's for resuming downloads and the like. So if you know you've already.
Oh, okay. Right. Okay. So it's at that level. Yeah.
It's at that. Well, I don't know if you can define different ranges. There's different ranges you can define if it's a byte range, or presumably you can specify a different measure. I'm not sure. I haven't read it. You know.
Okay. So Paul is with us. Hi, Paul.
Paul is muted. He's just chatting. And I thought maybe I could take a couple of minutes just to show this thing about matrix parameters that is supported in Rumba. And if you, okay, did you unplug?
Yes. Oh, should I have gone to something?
No, no, that's all right. I thought I could just. Does it reach? Okay.
Let's see if I'm very careful, it reaches. But you have to make yourself the presenter. And all that, so.
Yeah. Oh my God. Are you doing that for me, please? Don't know what happened to my screen now.
Who's Robert?
That's Foreman, sir.
Is he using Tor?
Hey, can you hear my audio now?
Yeah, I can, yes. Or we can.
Okay.
Do you want to do the demo yourself, or should I just go and you speak?
No, do whatever you were going to show.
Well, I just thought I'd show. I mean, this is the first thing I've done with Rumba and the matrix parameters, but let me start from the top here. I've loaded the Rumba workspace. I've created a new server. Can you read this, by the way, or should I maximize the...
Bigger would be better.
Right. So in Rumba, we create a namespace containing the parameters for a new server. You can see all the parameters by just checking in here. And all the defaults are set out there. So key things that are of interest is the callback on received request and the context of where these callback functions exist. So that would be a namespace reference. And the port. I think that's the most important bits to set. You could probably get away with ignoring or using the defaults for everything else. So in my instance here, I've created a server configuration with port 9002, and I set the context to the root. I have a callback method defined in the root here, which is receiving a message from a client. This is the famous stop here, please. Apparently, I can't remember, was it last SwedAPL meeting, Morten recommended the triple jot.
3 jots, a minimum of 3 jots.
A minimum of 3 jots. Don't use ... full stops or any other character, because that might be...
Skulls might make them do something.
Right. So here is the mechanism of preparing a response. So we're passing the message to this new response method, and it returns a response object which has properties that we can set.
Det är ett meddelande från receptionen och vi kan meddela att faran över. Det har inte brunnit till fastigheten utan larmet orsakades av lite matlagningsverk. Vi ber om ursäkt för olägenheten och önskar en trevlig fortsatt på dagen. This is an important message from the reception. We can inform you that there is no danger at all. There has not been any fire in the building, and the fire alarm started due to some cooking in an apartment. There is no need for you to do anything. We apologize for the inconvenience and wish you a very pleasant day.
Right.
It was a little late.
That was an hour ago.
I'm glad it wasn't.
You've already jumped out of the window.
I'm reading out there wasn't a fire.
You might have heard something a bit earlier if there was a fire.
Yes, Paul Mansur, you probably missed that, but there was a fire alarm going off earlier during Morten's presentation, which caused a minor hiccup. And everything is okay now, apparently. Right, the on-request property is defining the callback to call when we receive a message from a client. And finally, we need to start this server. So we pass that as a left argument to Rumba's core start method with a 0 argument, right? It's ignoring its right argument. And that's starting a listening loop. So it's just waiting for a request. And right, I can't start that on that port because it's already in use. So I'll change the port, and there we go. Now, is it safe to use a client on the same workspace, Paul? I'll start another workspace.
It is.
I don't know.
Should be.
Well, let's not experiment today. So
Chicken.
I'll start another session here. And let's see, we create a client similarly by calling Rumba core new client. And again, it ignores its right argument. We define the port as well matching, so 9001. The host is defaulting to localhost, so we leave that as is. And in addition to that, we prepare a request. So I need, let's see, core new request. And in this case, the URI is sort of important. And just to show what the matrix parameter might look like, if we have customer and we want to specify which customer we're talking of, we could say Adam and order, and we want to say the date is today, and the minimum cost is 1,000. So if we pretend that this is a RESTful request, this is specifying customers that have a name of Adam and where they have orders, where the order date is today, and the minimum cost is 1,000 something. I guess we could do that. So that's preparing the request, and I can then send that request by calling Rumba core send and receive, which basically is a shorthand way of making a request and then closing the connection. So it's opening up a connection to that on that port, making that request on that URI, and then closing it. And the reason it's split like this is to enable you to prepare multiple requests, multiple different URIs, and then send all of those, so a vector of requests to the same endpoint, and then close it after you've received the response for all of those. So that's why there's a split here on a client configuration and the request. So if I had a vector of 10 requests here, it would send them all and wait for all the responses to come back as a vector of 10 responses and present the result in one go. Yeah.
So what sort of
two row R as a run argument, send receive?
A 2-row R. Yeah, I think.
The request.
Yeah.
So how is that?
Well,
what sort of
see.
protocol is that? Is that just using just chaining them together HTTP requests one by one down the wire?
I believe so. Yes.
Okay. So they might not come back in the same order.
No, they will. It's pipelining in HTTP, and it's defined they have to come back in the same order.
Okay.
You might want to include that.
Cool. No, it's a scalar.
Oh, you mean enclosing R?
R is a scalar.
R is a scalar.
But,
right. So that's.
You might not really want to do that.
Well, I've got
If it's the same one, it's a reference, and I'm not sure when they come back.
Let's just, for the sake of testing this, if we do two. Well.
Is a chicken.
Right. So we've got 2 of those and 2 of those, and if we send that or send R, right, so omega is a vector of request, and the result is a vector of messages. And if I run that, of course it's crashing if I introduce the triple drop. But what we can see here is the message that the server receives contains plenty of different interesting things, like what was the URI originally.
Yeah.
I've got segments, the customer and order. I've got matrix parameters. Now you'll note that these are vectors of the same, well, basically as many segments as you've got in the URI. And the matrix parameters are parsed and delivered as name-value pairs in matrices. So segment 1 has 1 name-value pair, and segment 2 has 2 name-value pairs. So basically, this gives you an alternative way of filtering your resources or requesting resources from the server. And the advantage being that you can refer to the different segments here. I guess an alternative way to represent this could be to say customer order, or perhaps order would be enough as a collection, and then pass it a query parameter where you say customer name equals Adam, or even Adam. And of course this will need to be URL encoded, but you get the gist here. So order date equals etc, etc. And I think I should mention they're not mutually exclusive. You can use matrix parameters without query parameters, or the other way around, or both together. So if you're using query parameters, as I understand it, they apply to the entire request as a whole, whereas the matrix parameters are affecting individual segments in the URI. Right, I think that was
cool.
What I wanted to show, and this sort of gives you an idea of how Rumba requests are made and how to start a server.
Yeah.
I'm timed out. Oh well. I guess we'll have to close that anyway. So I guess if we get rid of that one, there should be a. Let's closed the connection now, hasn't it? Let's see. Yay!
Yay! Well done.
Right.
Okay.
Would you like to add anything, Paul?
I would only add a couple things maybe about what REST, maybe some clarifications about what REST is, or maybe not clarifications, maybe more obfuscations. But you know, I think the probably in the future we won't even talk about it as REST as something different. It's just really, I think REST was Roy Fielding's came out of Roy Fielding's dissertation, and I think he pretty much invented HTTP. And it's basically about using the web the way it's supposed to be used. And so it's a style. It's not a technology. REST is just a style of appropriately using the internet and getting the full value out of it. And so it's about using resources, which are, you know, I think Morten talked about defining all your resources, which, you know, have URIs pointing to them, representations of those resources, so things can come, you can ask for stuff in, say, you know, there's a resource, but I might want it in JSON, or I might want it in XML, or as a PDF, or what have you. And all of those formats, of course, are totally independent and have nothing to do with REST. They are just whatever, any sort of representation of a resource. And then you have a uniform interface to operate on those resources, which are the HTTP methods or verbs, get, post, put, and all those things. And that's really it. And I think an interesting, I kind of understood it when I implemented something that was, as Morten says, when you know what's not REST, but my first interface to FlipDB was a command interface or a remote procedure, RPC calls, where I had a whole list of things that I wanted to do, and basically everything was tunneled under a post. So if you wanted to get something, delete something, or do something, you would send a command with all of the parameters that were necessary to execute that command. But everything was tunneled under a HTTP post. And that's clearly not RESTful because you don't have a set of resources. You basically just have a single endpoint that you are trying to do everything under, and you don't get any of the advantages of caching. You don't get any of the advantages of all of the verbs, and you don't have a simple interface. People need to understand all your commands. And if you add something new, you have to add a whole bunch of new commands possibly, like I'm going to do some new thing I want to delete or some new thing I want to deal with. Whereas if you stick with these standard HTTP verbs, you get a lot of power out of that, and you define resources, and it becomes much simpler. And you also get all these benefits of things like caching when you use it right. So I just wanted to kind of point that out.
That's a good point. Yeah, I think when I've read about it as well, it's been a repeating subject that RPC isn't REST. And,
yeah, I mean, it's a good point, and it's probably one that, you know, just by hearing Paul say it, you don't understand it. You need to actually
try it out.
Get it wrong a couple of times, and then maybe you'll start to understand.
At the edges of this, there are considered various levels of REST, and if you call something RESTful that is not the top level, you will get shamed. And the top level includes, I think somebody else mentioned there, the fact that your representation should include links to all of the things that you might want to do or do next once you have that representation in hand, once you do a get. And the analogy is kind of how you use the web as a human being, right? When you're a human being, you go to the web, and you just know one endpoint, Amazon.com, and then every page that you go to, you just click on things, and the page itself knows the next things that you want to do. So in theory, you should never even have to know all of the other links and resources, because the first thing that you get to has everything that you need. And that people are kind of making the cases that machines can do this too, and at the top level of REST, that's how it ought to work. But there's a lot of people arguing about that, because
it's easy in theory.
It's not exactly clear how that would work with machines, but
okay.
So the first thing you learn in REST is that you should have all these nicely, clearly defined resources, and then you learn that, well, none of those really matter, because the client should be able to be written in such a way that it only needs to know the first one, and the rest are all exposed automatically. Anyway, that'll confuse you. Let's not go there.
Yep.
I also had mentioned that HTTP 2. I'm dealing with HTTP 1.1, and 2 is a whole different animal. It's not simply a few things tacked on to 1.1. It's a completely different thing, and it's not like I'm skeptical whether we'll ever go there. I don't know. It's not also clear how it relates to RESTful style architectures versus web pages and stuff, because I think it's really optimized for web pages. Anyway, that's
About that in 20 years, it's finally picking up some.
Anyway, there's a lot of neat stuff in there, and there's more stuff. I'm getting ready to add conditional requests to Rumba, so it'll handle that stuff too, which I think can largely be handled not by the back application, but by Rumba itself, which is nice. And
can I ask quickly? Sorry, do you host this Rumba code anywhere for people to download, or are you happy that I give them what I got from you?
You can pass around what you have right there. I think I left it with Kai that we're hosting it, but it's not really open to the public to download. I think I could be wrong. I'd have to ask Kai about that. I don't think it is, but I'm happy you can just pass it around. And I was getting ready to discuss with Kai once if you start using it and are interested in it, that we would open that up and try and get it put somewhere where everybody can get the latest version and so on.
Right. Okay. Sounds good.
Excellent.
Thank you for joining us.
Yeah, thanks.
Sure. Thanks for having me. I hope you recorded your earlier talk so I can watch that later.
You don't want to see that, Paul.
Some of them were recorded. How many did we?
I'm happy to have a separate session with you, Paul.
Okay, yeah, I'm interested in the WebSocket stuff, so later on we can talk about that.
Okay, great.
Yeah.
Right, well, it's time for coffee.
Yep.
All right. I'm going to sign off.
Okay.
Thanks.
Thank you. Have a nice day.
Thank you. If any of the people trying to run this had any problems, just grab me during coffee. Yeah. Cool. Coffee.
Unmuted.
Supplier capacities, and also in the long-term planning for next 10 years, what new models will they have on what volume they will sell at. The second system called CPAM, which is an acronym that I haven't printed out here, stands for Commercial Product Authorization Master, a system that handles the product data, how the car sort of say hangs together, how you specify a car in an order, and then all the way down to the nuts and bolts and bill of material, the parts that are assembled into a car. And also some technical data. And finally, the third system, or actually a group of systems for the financial side, main user group there is those working with product cost control. And all these systems today, they have a somewhat different history, but today they all share the same principal technical setup, to large part running with shared code in between them. And web services is one important building block in how they work. So the history then. First use of web services was in the CPAM system about 15 years ago. And at that time, the system was running in VM. Then it was migrated to Windows, and then started using Dialog APL, using TCP socket, but still using custom functions built on the VM side and for handling HTTP, SOAP, and XML. A few years later, we started moving over to Conga, and yet another couple of years later, when the other two systems, Hercules and Mecca, were migrated also from VM to Windows, we started to move from using our own XML functions to make use of Quad XML. Some numbers on it. The way we use web services are both for making services available for other systems and for making services available for other parts of the application itself. So, for example, for Hercules and Mecca, we have an executable that is running as a fat client on the user PC. But for certain things that cannot be done in the local PC, we have web services on the server side making that functionality available. Similarly, for the CPAM system, we have a front end consisting of a web application, and the web application is then supported by the core CPAM system through web services. And so from the numbers, it's fairly obvious that the most intensive use of web services is in CPAM. So it looks a little closer of how that system is constructed. It looks somewhat like this. The end user is using the browser. Internet Explorer is the only browser within Volvo cars, basically. And the middle box here is the entire CPAM application running in one Windows server, but it basically consists of two parts. The left part, which is the web application, and the right part being the application server core application. And so the communication here now from other systems towards the CPAM core, as well as from the web application side, is done through web services. Some statistics, just to give an idea of how much the usage is. I took the log last week for 24 hours to see what the usage was, and during those 24 hours, 111 different services were used. in total 36,000 requests, and it spreads out over the day with a peak during office hours. The absolute peak, 13 requests in a second. So fairly high amount at least. And looking at how it breaks down, I mean, what's listed here are the different services and how much they were used. The names as such, of course, doesn't mean much, but as you can see, they are quite unevenly distributed. So, in effect, one service made up 2/3 of all the requests. This top 10 list also somewhat shows how the division between different users of services are, because the first top 3 there are for external systems that are not one of these APL systems. Then the middle 4 are for the web application, and the last 3 are for the Hercules application. So going
Peter, we can say about the 2 first. That means that if CPAM stops, there will be a hell of a cry in the company, because the second one is every. Will you say this?
Yes.
Oh, sorry. I thought you moved over.
So if we start looking at a simple example of how tightly interconnected our systems actually are with these services, this is a screenshot from the Hercules system, which is a Windows application, although it still looks like a VM application. What the screen here does doesn't really matter, but on the left side there, what I've done is I've entered a code, an option code. And to get to the right side, what I've done is I've pressed enter. And when I press enter, I'm supposed to get the text description for that code. And the code there, the option code, as such, the Hercules system doesn't know what that is really. Because the Hercules system, for everything product structure related, it makes use of CPAM through web services. And so even such a simple thing as to look up the text for this, it has to go to CPAM. So if I run this in the debugger, the actual cutover point here is in a function calling query CPAM. And the way it's done then is that we send in 2 parameters, the first being the name of the service to use, and the second being the actual parameters to that service in XML format. And so the actual request being sent will then look like this, saying that I want to know what 000790 is. And also we pass along the end use name. So piece Simon 15 there, that is telling for traceability that it was me initiating this request. And then I get the result back with that text. And then the function making the call unpacks the XML and returns it in the format that we need it on the APL side. External systems then. We service a number of external systems. The 2 most important probably are these 2. The first one, ARO, is the factory ordering system at Volvo Cars. So they use CPAM services to check every single order being placed. And so if CPAM doesn't respond to this, basically, it will eventually stop the order flow and down the line cause a problem in the production. The other one is a global car configurator, which is basically a configuration engine for specifying a car used both in the ordering system, but also in web-based configurators such as the one you can use on volvocars.com website. And they use CPAM for a couple of different things. And they are the ones using that service that took up 2/3, as you saw in the first list there of the statistics. So that system is really the one actively pushing us to have a high availability, because of course if this system is unavailable, it might not immediately stop things, but it will make you look bad, so to say, in the eye of a customer perhaps. So a simple example of an external request. This is from GC then, a weight calculation, where they send in an order specification. So all these numbers basically mean what kind of car, what engine, gearbox, and so on, what color, what upholstery, and what extra equipment is put on it. And then CPAM returns back how much does it weigh, what's the fuel consumption, what CO2 emissions, and so on. So to process these requests, we need some kind of load balancing, and the way we do that is by having a master process that receives the incoming request, but then the actual processing of them are spread out on a number of slaves. And so master is responsible for listening on the public port. When a query is received, it is first checked to see if it's valid. If it's not, it is rejected with some kind of error return, invalid transaction, unauthorized. If it's okay, it's placed on queue, and then as soon as a slave becomes available, the next request on queue is passed on to that slave. The slave executes the query, returns the result to the master, which then returns the result to the requester on the kept open connection, and then closes the connection. And the way we set up it, we have the number of slaves is configurable, so we need to increase it. It's just a matter of updating a table, basically. All of it is running, both master and slaves are running as single-threaded processes using Dialog RT, and we start them up as Windows services using SRV Any. Incoming port, the communication to the master is of course HTTP based, but between the master and the slaves we use the Conga command mode so that we can exchange the data in APL form rather than in XML. And to a large extent we also make use of keeping data in memory or in the workspace to speed up the handling of the requests. Access control is of course quite important because to some extent this is data that shouldn't be available just to anyone. So we have a handling for who should be able to use what services, and basically we keep, for system, we keep a table of what system has what IP addresses, and then for each service who is allowed to use it. But then since we also use services for example the executable client for Hercules and Mecha systems, we need to be able to do it for a user that doesn't necessarily have a specific IP address. So there we use an authentication instead, which is based on IVA. We don't actually use the built-in one in Conga, but it's the same principle. And the reason why we don't use the built-in one is because we need to do it from Excel add-ins as well. As far as possible, we try to, of course, make the services execute quickly, short response times. But what we're handling here is quite complex data. In some cases, queries are not so easy to speed up. And also, sometimes we're treating a lot of data. So the transfer times are also a problem sometimes. To make sure that something simple, service that can be answered within 10th of a second or something, doesn't get blocked by a larger service that could take a couple of seconds, perhaps, we tie different services exclusively to some slaves, so that, for example, a time-consuming service may only run in slave 1, for example. That way, it will only block other long-time services, but quick services can execute in the other slaves. And another thing that we recently came across was that when we have a large arriving query, the DRC wait loop would keep returning all the blocks of that query rather than let any other small queries arriving through before it had completely processed that large request. So what we had to do was put in some strategy of doing some more specific wait calls to make sure that if we're processing a large incoming query and there's a new connection coming in to do something simple, we let that through.
Can you control that?
Yes, but what we're actually done is to wait for the next connection with a 0 timeout.
Okay. All right.
What's a simple solution?
Mm-hmm.
And another thing is, of course, availability, where, as I said, we have some high demands on that from the external system making use of us. And we've had some problems recently, especially after having moved to virtual servers. So now there are talks going on that we maybe will be running this in a failover cluster. So if anyone has experience with running a dialog application in a Windows cluster, we're very interested in knowing more about that. And then a final thing, that sometimes this XML stuff is somewhat of an overhead, of course, both in that it inflicts the data and it adds processing time. So especially in between our own APL systems, we have in the last year started to move towards exchanging data in APL form instead, but still sticking to the same setup that we use for the proper XML-based web services. So in Hercules, for example, we even use the same master slaves to deliver both XML and APL-based services. Yes, that's what I had. Any one of you from the Volvo Cars side that would like to add something that I have forgotten, perhaps?
That ready strategy, is that worth commenting on?
Yeah, I'm curious.
I'm a little puzzled on how you're doing it, because you're not allowed to wait on 2 levels in the same tree at 2 levels. But what you're doing, what are you doing to kind of just wait for a new connection without accepting data for one of the connections beneath that server?
What is it you're waiting on? Is it the server connection?
No, I mean the normal for in the loop receiving blocks. Wait if you wait and you get a block and you append that to some buffer and then it goes back. Wait again, get another block and so on.
Yeah, for one of the connections.
No,
you're on the server side.
The basic wait is for everything.
Right.
That is empty quotes. Oh, yeah.
On the server socket.
Listening on the whole thing.
Yeah. Right.
And then you get block by block by block. And the problem is that if you do another wait, even if there is a new connection, that doesn't get reported by that wait until it has gotten the block lost.
Really?
Yeah. But how would you then get the connection, the new connection, without getting the next block?
So what we do is that we do wait for the name that will be on the next connection with a 0 timeout.
Oh, you're constructing the next consecutive number.
Yes.
So you're generating the next connection name and waiting for that with a 0 timeout.
Yes. And that will then immediately return that connection actually.
If it's there,
yeah.
Hmm.
That's neat.
Yes, somewhat of a hack, I think,
well,
but that was the only thing that we could devise at that time.
Is there a risk of doing this? Yeah.
No, not if you're doing it that way.
I mean, it's a risk, of course, if you would change the concept of how you construct the connection names.
Yeah, but I'm pretty predictable, you know.
Right. Okay.
I will leave out some prime numbers.
So 2 questions on that point. Are you receiving that big requests that you would have to do this?
And the reason why this came up as a big problem was that we introduced.
Your cable is.
Right. That we introduced a service to update data in the system, to publish data. And in that case, it can be quite large.
What size are we talking about?
10 to 20 megabytes or something. But the thing is that it originates from possibly a slow connection. So I don't know if that has any.
What is that client end?
Client end in that case is an Excel add-in.
Yeah, okay. So it is just a raw text connection.
Yes, it is.
And the next question is, of course,
because we don't have this problem, of course, with the command-based in any way. There you don't see this.
No, because in that case, I know exactly how much to receive, so I would receive it in Conga and then just pass it to APL when it's done. But when you're on a text connection or raw connection, every time I receive something, I would try to return it back to APL as soon as possible, because I have no idea whether I'm done or not done with the problem. And if you're on a slow connection and it's coming in very small chunks, you will get it maybe 5 bytes at the time, and you have to concatenate these 5 bytes to what you have received, and that would spend up a lot of APL time just doing that.
Right. So how does Conga deal with this? If you get one incoming connection with 20 meg, and then immediately after is 5 byte payload, will it process that one even if it hasn't received all the data? I thought it was just returning whatever it gets in.
Yeah, that is exactly what happens. I'm returning exactly what I get in. When I receive a chunk on the socket, I just pass that directly to APL. And maybe these chunks are obviously coming in small chunks, or maybe just because there's 10 megabytes, a lot of chunks.
Right, but do you not? I mean, does it stay on the first connection until it's completed before it's starting to pass on data from a second connection? I mean, why would he have to do this? I thought if you're just passing through whatever you get.
My suspicion is that all the chunks would be received pretty fast in Conga because it's not taking me quite a long time to do that. And then a new connection arrives. But since I'm returning all the things I have received in order of
I see.
in the order that I received them,
Right.
all the small chunks would go first, and then eventually the new connection will come in last.
Right, so they're still being served in the right order that you received them.
Yeah, but there's just a lot of them.
Right.
Yeah, because if you run it in debug, you will see it spinning in the loop, basically. I have heard that problem before, and we have some ideas on how to kind of amalgamate two buffers if they are received pretty close to each other. Or maybe you could set a timeout and say, I want, if anything received within 50 milliseconds, I should kind of glue together. But this problem would go away if the HTTP stuff would be available in Conga, right? If it's an HTTP request. Yes, it is. And you have set the content linked. Yes. If it is a I know, yeah, you just know how much
it's chunked.
Yeah.
Right. I'd like to see this posted somewhere. So it's a good trick. I didn't even know we could end up in that situation.
Yeah, it's very simple to emulate. You can do it on your own. Yeah. I mean, just start a server and then start a client sending something.
Yeah.
And another one connect to it, and you will see that it will process the whole large data before accepting the new connection.
Right. Okay.
You could change your Redis strategy to one of the round robin ones, where you would take the first thing after on each connection, and then switch the connection to the one you handle last. I think it's Redis strategy 2 or something like that. But then you would not be sure that you would get your data in chronological order, but you would avoid this problem. And you could construct some cases where you would start some connections. Say they would handle very slow compared to other connections.
But isn't that what happens here? That the short request gets starved in favor?
Yeah. Because if the large one takes maybe 10 seconds or something, and just as that started processing or started arriving, someone issues a short tenth of a second thing, they will have to wait 10 seconds rather than 1/10 of a second. So in that case, you should probably choose the other Redis strategy, because you don't care too much about huge requests getting slowed down, where you favor kind of the small request. Yes. And that one of the other strategies would favor that. How do you change that? You set it on the root. So which Redis strategy you want to use.
What was it called? Ready strategy?
Yeah. Okay.
I need to read about that.
But isn't it, I think we have a discussion about this about email before, but isn't it so that the ready strategy only matters if you do several waits before you do send? That is, if
the ready strategy controls how to.
No, if you do several sends before you do the wait. There was something, because we have a server socket that really is long with wait, and then there's a request coming in command mode with Conga, and then the request comes in and we process it and we send it back out with send to that particular client, and we go into the loop and wait again and do the next request.
Yeah,
and I think we had a test case where we did a stress test and tried to see if ready strategy made a difference.
Yeah, but as long as you're running in command mode, I know exactly how much to receive. I will not pass it to you in chunks.
No.
Where they are kind of working in chunks and getting maybe in small chunks because it's a slow network. So they would be hit by that.
Okay. But Peter, you don't have the content length.
No, but it wouldn't help.
I
mean, we have the content length. Since we have, the first thing we read is the HTTP header, and there you have the content length. But I mean, Conga doesn't have the content length. So Conga will keep returning small pieces, and we need to glue them together.
Yeah, you cannot tell Conga to receive it all at once.
No, unfortunately not.
Not yet, at least.
No, but unless you have an end marker that you are sure of. You have that in a...
Nope.
It's getting dodgy.
You just have the... Content length of the HTTP header is all we have. Yeah.
We should talk more about the solving.
Yeah.
Solve it.
Interesting.
Because this whole thing with chronological order, that's also, I think sometimes we would also be interested in not having that requirement. We talked about it before, about walking that data structure and trying to deduce a chronological, just call select on all sockets, and whatever is ready is when it's ready, and that you signal APL, and then when you APL asks what's ready, you just pop them up in order. When they, like a global queue, it's DRC.wait, not handling different.
But then Peter would not be able to do his hack to get out of that.
No. You would not.
Yeah. That's another.
But then you would receive chunks in just the order in which you called select on all sockets, and then would that be the case then?
Yeah, the chunks wouldn't drown out connection requests if you were just to deal with it.
I think the problem is that it's receiving the chunk is not a problem in the C layer, but returning them to APL it becomes the time-consuming thing.
Yeah, I think so too.
Yeah, because now you have a data structure, you have a queue or a buffer per connection, and then you walk, when you call wait, you search among the connections to see which one should I return now.
Yeah.
But my point, what if you have a global queue where everything that's completed just gets added, then as it's complete, then you wouldn't have to search the data structure.
No, but still you would have to have all the small chunks. You would have to go through all them before you.
Yeah, definitely. Yeah. He would still receive lots of chunks, but they would be interspersed with.
But I mean, another optimization we talked about is that if there is some data in a buffer and another piece arrives and it hasn't been picked up by APL, you just extend the buffer and it only becomes one event rather than being an event for every 5. I think that
would be really nice.
That would be really nice.
Yeah, but that is not extremely easy to do.
That's why we get paid, Jack.
I want to get paid more.
You the big ones.
You get more.
Sorry, are you getting paid by chunk?
Otherwise, I would just return everything in one go.
Right.
I have to make it look like something, you know.
Actually, I thought it was very interesting your structure with the servers and worker processes or slaves, as you call them, because we have, of course, the same issue that Dialog APL uses a single operating system thread, and how do you handle many connections?
Yeah.
And we did a similar thing, but we don't have a single front end, so we have lots of servers listening on lots of ports.
Yeah.
And then the client, since our client is APL as well, it just spreads out over different ports. And then we have different port ranges for example, potentially slow requests, just like you had specialized worker processes for potentially slow. So
we have that before.
Yeah, and that won't work, of course, if everything is over HTTP port 80. So then you have to bund it out on the inside.
Yes.
Yeah, I was thinking Apache load balancing. If you know the services are using a specific URL, you could up the Apache and just distribute it. So it's redirecting it to an APL server on a specific port. So if you've got slaves 1 through 10 and you want to have that top service working on slaves 1 through 5 on the Apache configuration level, you could say any URL that starts with this service pass it to these slaves.
But then you get, that's a good idea, and that's a very scalable idea, because then you can scale out Apache and put load balancers. But having a single queue like you do now is very efficient, because then as soon as any worker or slave is ready, it will take the next request. If you do what we do, because we have lots of processes and we didn't want coordination, you just distribute them, which you can do with Apache as well, or a HTTP load balancer. Then, of course, you get the issue that stochastically you get lots of requests coming to a single worker, and then they queue up. Or if you have a single request taking a long time, other requests might arrive after that. So you get worse latency, but better scalability in terms of number of processes. You don't have a single point of coordination like the master process.
Right. I can no longer see Denmark. I don't know what happened.
You can barely see Malmö.
It's disappeared. Thank you very much.